Hello and welcome to Devfest 2020. I'm Jason Titus, VP of Engineering at Google, joining you from my home in California. Each year, we at Google truly feel the anticipation for Devfest. It's a one-of-a-kind series of developer conferences, and we're glad you can join us and the local developers within your community. Your local Devfest event this weekend is one of hundreds taking place all around the world right at this moment. And what makes Devfest truly unique is that it's run by volunteer community organizers on a mission to help other local developers grow and share a passion for Google technologies. Now, 2020 has been a year of radical change for people across the globe. But when difficult times came about, developers within this community came together online to plan a virtual Devfest where each local chapter could participate, helping each other teach and learn when we need to connect the most. And these connections can be so important. I can remember the first developer conferences I went to, where I met people who were already doing the kinds of things I dreamed of doing. They had started companies, built products, and I got to hear the stories of what had worked and what had gone wrong. And we hope that all of you will get to have similar experiences at Devfest this year. At Google, we've always believed that we are only successful when all of our users are successful. While Google and its products may plant a seed, it's developers like yourself who make the seeds grow and thrive. This community of developers has shown us firsthand how you're using technology to help each other during times of need. Let me introduce you to my teammate David to share with you some great examples. Welcome, David.
Hi, Jason. Thank you. And welcome everybody to this year's Devfest season. I'm David McLaughlin, Director of Developer Ecosystems at Google. So I've been with Devfest since the very first year in 2010, when I was able to join a large percentage of them. Back then, they were a series of targeted events in just a handful of countries. In the years since then, we've had massive growth to countries all over the world. While I really do miss being able to join many of you in person this year, I'm happy to be able to continue the celebration of developers and tech in a new virtual format and bring people together to learn and to share what we're all building. Over the years, it's been great to see the apps and the solutions the broader community has built with the support of their local GDG chapters. We now have thousands and thousands of developers who are working to address real-world problems in their local communities. Particularly during the challenging times of COVID, I'm impressed by how much your work has made people's lives better. There's a few recent examples that truly stand out to me. Community developers from GDG West Sweden recently worked with the Swedish government to create Hack the Crisis, an event focused on designing, testing, and executing ideas in response to recent challenges. One of the finalists, named Remote and Gigs, helped modernize the Swedish government's employment website to match job seekers with remote work. Nearby in Romania, GDG groups organized a hackathon, gathering 270 different mentors and students from across 8 different countries. The hackathon brought together developers to save lives, to save communities, and to save businesses. Some of the winners included an online platform that connected volunteers with nonprofits across the region, a system to help doctors work with each other and to ease online consultations, and a personal assistant for health and nutrition tracking. Another cool app that they developed was Risk Alert, an app that alerts emergency rooms that a patient with a very rare disease is about to arrive so that the hospital can prepare for any special needs. In Asia, GDG Tainan initiated the Mask Inventory Map at the start of COVID-19, which crowdsources mask inventory from local store data, combining it with the Google Maps API. The project was so popular that it caught the attention of Taiwan's government, inspiring them to publish public data APIs on mask inventory managed by the government. Taiwan's digital minister has since encouraged the GDG Tainan chapter to create more than 100 different apps to help the local community. In India, GDG Cloud Pune used machine learning with TensorFlow and GCP to help their community with an app that remotely analyzes dental health and helps patients book at-home dental services. They've had over 300 trained images so far, and the developer community is working with local universities to gather more than 50,000 dental images to improve the application. In the Middle East, the region's largest International Women's Day event was held in April in Turkey by multiple GDG groups working together. They had over 2,500 attendees to the event, which included a raffle for online courses and talks in artificial intelligence and data mining. The event helped women across the community and across the region learn and apply their skills. And of course, here in the United States, the GDG Memphis chapter has joined GiveCamp, where software developers in the area donate their skills for nonprofits, as well as helping kids learn to code on the weekends. These are just a small sample of the ways that Google Developer Group chapters and communities like yours all over the world are learning together and giving back what they've learned to really help people's lives everywhere be better. I encourage all of you to continue, be in community with your fellow developers. Think about how can you use the skills and the tech that you're learning this weekend at Devfest, as well as the networks and the communities that you form, the new friends that you make. How do you combine all of these to make a difference in your own area? Now let's take a look at a really inspiring story from Uganda. It shows how a community member started learning about machine learning and ended up building a really nifty app using TensorFlow that detects diseases in plants and helps farmers reduce crop devastation. Take a look.
Growing up in the city, I never expected to work in agriculture. But when fall armyworm attacked, it affected us all. Since its arrival in 2016, this crop pest has caused massive devastation. I've met farmers who have lost everything.
Tubadde tukozesako ddagala okulaba nti akako kulya ki kasooli naye akantu ako tekayinza kumalawo obulwadde obwo ssebo.
So I wanted to use my skills as a software developer to help. At a Google Study Jam, we taught ourselves TensorFlow. We started by building an Android app on top of an open source API. The app allows farmers to spot infestations early, far beyond the capability of human eyes, and suggest an effective treatment. When I was younger, I didn't know what I wanted to do, but then I discovered app development, and I was excited to show people something they never thought possible. Machine learning gives us the advantage against fall armyworm, ultimately saving harvests and reducing pesticides.
Kunkyusizaamu kubanga taata oba jjajja teyalina ennyumba y'ebbaati. N'ebbaati nazimba ennyumba yange nga tetoonya, tulina essuubi ne tufuna embeera ennungi mu kulima.
We are just getting started, and there are so many other sectors like health and education that machine learning could really improve. Farming is a crucial aspect of life in Uganda, and I feel proud I'm part of a team driving to ensure our culture can continue.
Earlier, you saw a beautiful inspirational video about how machine learning and Android were used to create an app to detect crop diseases. So for Devfest, I wanted to get together a few of my friends from Google and beyond to show you how you could get started in building something just like that from scratch in a few minutes. We'll build an Android app and a web app. So to get started with Android, let's see what Chet can teach us.
I want to create an app that's able to recognize information about plants. It's going to need camera functionality as well as machine learning inference. Let's see what that looks like in code. The app is written in Kotlin and uses Camera X to take the pictures and MLKit for on-device machine learning analysis. The core functionality is in Take Photo, where we take a picture, analyze it, and display the results. First, we call Take Picture on a Camera X image capture object that was created earlier. One of the parameters is a callback object, which has this on-capture success function. We get the received image into the format we need for MLKit, then we create an image labeler object and process the image. When this succeeds, we receive a collection of image labels, which we turn into text strings and display a toast with the results. Let's see what the demo looks like. So we'll take a picture and it says, I see an insect and a plant. So that was pretty easy, rigging up Camera X and MLKit to detect arbitrary objects in the camera view. But the results were pretty generic because the dataset didn't have enough information about our domain. So let's dig a little deeper.
Okay, let's go deeper. Now we need a model for something very specific, detecting diseases in bean plants instead of cassava. Let's explore how to build it. On this guide, we will use some of the great TensorFlow tooling available. Let's start with Colab. You can understand Colab as a cloud-hosted development tool. We will do all our coding on it, and you will not need to install anything on your machine. Let's start with a new notebook. Let's just turn the title to beans. We will need to install some packages that we are going to use later. These packages are not installed on your machine. They are on a cloud machine that was created for your Colab. Nice, it finished installing the packages. Let's download the data and do some visualization to understand how our data is separated. Perfect. We download the data. Let's take a look on some of the images so we can have a better understanding of what we are doing here. Here they are. These are some of the images that will be used for training our model later. Now we have the data. We need to create a model. We are not going to create one from scratch. We are going to use a technique called transfer learning. TensorFlow Hub is a repository for TensorFlow models. You can find all kinds of models here. Let's start with this one. Let's go back to our Colab. Let's define a model handle. Nice. Now we have the data and the base model. How can we do transfer learning? To do that, we are going to use one of the tooling that I mentioned before called Model Maker. Model Maker makes your life way easier when you need to do transfer learning. Let's create the spec for our base model. Let's create our training variables here using the dataset beans that we've just seen. And now we're going to put everything together with Model Maker by defining a model with the training data and the spec that we got from TensorFlow Hub. This will take a couple of minutes. It finished training. And as you can see here, our accuracy is at 87%. Of course, let's evaluate the model with some data you didn't see yet and see how good it is. Nice, 95%.
The TensorFlow Lite model Gus just created contains all the metadata Android Studio needs to recognize it and automatically build classes for it. To get started, you can update your build.gradle file to include the following TensorFlow Lite dependencies. Then, you'll want to import your generated TF-Lite file into the ML folder of your project. Let's check out the details of our imported model. From here, we can see an example of how to use the model in our app. Let's move over to the main activity class to take advantage of it. Inside of our image capture callback, here on line number 78, we create an instance of our model. Next, we use it to process the captured image here on line number 84. And finally, here on lines 92 through 98, we display the results of consuming the output inside of a toast message. Let's run our app. Now, instead of telling us it's looking at a leaf or a plant, it can actually tell us if it's looking at a bean leaf and give a diagnosis. Sweet.
So this concept works, but it's very much a raw demo. What if we want to make this a more successful app? Well, we probably need to add services like authentication so our users can sign in, analytics and A/B testing so we can find out how our users are really interacting with our app, some crash reporting or performance monitoring, and an easy way to save our users' data to the cloud. Luckily, that's where Firebase comes in. Now, the new and improved Firebase plugin in Android Studio makes this simple. I'll start by adding some analytics so I can find out exactly how our users are interacting with our app. And the plugin does most of the work to get the library integrated into my project. Now that I've done that, well, we can get an instance of the library up here, and then we can log what kind of results we're getting from MLKit. And then once we've done that, there's a lot of ways to get at this data. It'll start showing up here in the Firebase dashboard, but I find one really fun way of viewing this data is to use Stream View, which kind of gives you a real-timey sample of what kinds of analytics results we're seeing. Looks like I've already recorded several of these select content events, and I can dig into these event properties and see what kinds of results our users are getting, and I could start using that information to maybe refine my MLKit model or A/B test different alternatives. Firebase helps you build better apps, and analytics is just the tip of the proverbial iceberg. Maybe we could let our users upload their own pictures and store them in the cloud using cloud storage for Firebase. There's so many possibilities.
This is a sample app, but if we were to productize this, it's important to keep in mind how our AI design decisions impact our users. For instance, we need to consider if and/or how it makes sense to display confidence intervals to help your users interpret the ML model output. Or say how you design the onboarding experience sets user expectations for the capabilities and limitations of your ML-based app, which is vital to app adoption and engagement. For more guidance on AI design decisions, check out the People Plus AI Guidebook at pair.withgoogle.com/guidebook. This use case focuses on plant diseases, but for other use cases where our ML-based predictions intersect with people or communities, we absolutely need to think about responsible AI themes like privacy and fairness, which you can learn more about at tensorflow.org/resources/responsible-AI.
And don't forget about the web. I built a PWA that can be installed across all your users' platforms. It combines the web camera with TensorFlow.js, and by integrating machine learning, we can make an amazing experience that runs across all browsers. Now let's take a look. We have our standard project layout with a HTML file, a manifest, and a service worker to make it a PWA. We have some styles to make it look good, and our data folder that contains our TensorFlow configuration and trained model that we're going to use in the app. Now to the heart of the project. Let's go back to the HTML file and see what's happening. We're also loading a webcam object. This is just a class that wraps some boilerplate logic to make it easier to pass camera data from GetUserMedia to TensorFlow. And now let's dive into our app logic in index.js. So I'm just going to use Chrome and the debugger here. And this is only so you can kind of see how easy it is to integrate machine learning into your application. So let's get started by clicking the classify button, get the machine learning gears into action, and immediately we break into the TensorFlow tidy function. This is just there to help you kind of clean up any of the memory that TensorFlow uses whilst it makes a prediction. We get our image from the web camera, and then we pass our image back into the machine learning algorithm to make it a prediction. And once we've gotten prediction, we access the data, and then we can use that data to update the user interface kind of based on any application logic that we want. And that's pretty much it.
Great. So now you have the platform for building a real app. With the tooling from Android Studio, the APIs from CameraX, Jetpack, MLKit, Colab, TensorFlow, Firebase, Chrome, and Google Cloud, you have a lot of things that just work better together. This isn't a finished project by any means, just a proof of concept for how a minimum viable product with a roadmap to completion can be put together using Google's developer tools and APIs.
You might also want to open source this project too, so developers can suggest improvements, optimizations, and even additional features by filing an issue or sending a pull request. It's a great way to get your hard work in front of even more people. We'd love to help you with this, and you can learn more about the process at opensource.guide/startingaproject. Indeed, we've already open sourced the bean disease sample we discussed in this video, so you can have a great place to start.
Thanks, Pooja. And as you mentioned, open sourcing a project is a great way to make it grow and inspire people to adopt and extend it. If you want to learn more about what you've seen in this video, please visit us at developers.google.com.
Hi, developers. My name is Annie Jean-Baptiste, and I'm the head of product inclusion at Google. The demo you just saw shows how Google's products can come together to create an amazing app. But what about product inclusion? You may be wondering, well, what is product inclusion and why is it important? At Google, we believe that giving power to new voices is the core of innovation. When we bring an inclusive lens to the product design process, we amplify underrepresented voices and allow all users to feel seen and validated in the moments that matter for them. We look beyond ourselves and seek out diverse voices to shape the products that we build. We also believe that we have a responsibility not to disappoint our users, no matter who they are, what they look like, how much money they make, who they love, how old they are, or anything that makes them them. And when we make difference the new normal, we will usher in new opportunities to grow our business by earning the love of all of our users. So whether you're 1 or 105 years old, live in a city or a remote village, on Wi-Fi or cellular service, Google is there for you to make sure you have the answers you need when you need them. Product inclusion is exactly what it sounds like, bringing an inclusive lens throughout the entire product design process to create more inclusive products for our users. And so when you're developing your own apps, I challenge you to incorporate the principles of product inclusion into the design process, because we believe that you can do well and do good by being intentional about including underrepresented voices at key points in the product design process. Remember, those closest to the problem are also closest to the solution. You can learn more about product inclusion at Google by visiting accelerate.withgoogle.com. Thanks.
Hi, everyone. My name is Jen Cole, and I'm the Global Developer Communities Program Manager at Google. Now it's time to meet and hear from your local developers. So what can you expect next from your local Devfest? We'll have technical talks, breakout sessions, networking opportunities, and more. These sessions will cover a variety of technologies, such as Android, Google Cloud Platform, machine learning with TensorFlow, web, Firebase, Google Assistant, and Flutter, with speakers from Google, women tech makers, Google developer experts, and your local community. Be sure to claim your badge for participating in Devfest 2020 by going to google.dev/devfest2020. You can earn even more badges by mastering different Google technologies available on developers.google.com/learn. As a reminder, one of the most important parts of Devfest is providing an inclusive and harassment-free experience for everyone. As an active participant of Devfest, today, we can all agree to treat everyone with respect and to speak up if we see or experience harassment of any kind. Together, we can create an environment that is welcoming and inclusive to everyone with us here today. Follow @GDG on Twitter for highlights from Devfest around the world, and try out the Devfest AR filter and avatar. Share what you're learning or your favorite part about the event on social media with #Devfest. And lastly, don't forget community is all about getting to know one another. Use the virtual breakout rooms and chat feature to connect with other developers near you with shared interests. We hope you enjoy Devfest 2020.
Including some cutting-edge stuff such as multi-cloud solutions. We foster strong partnerships with all leading cloud providers.
Okay, so welcome to our Devfest. This year is 9th time we are organizing it in Poland. And I would like to say at first about GG history. It was established almost 11 years ago. It, in the years, transformed into Google Developers Group. And now, as you can see, we are quite big community that is in direct contact with Google engineers and helps community grow and learn. We are trying to inspire developers everywhere. GG Worldwide is in 139 countries. As you can see, this official map, we are almost everywhere. We have almost 1,000 chapters in different cities. So if you are trying to do something for the community, it's a great place to start. Look in your city in the Meetup or GG community.dev webpage. This year's edition is brought to you by few chapters. We are in Poland over 10,000 members strong in Meetup, and we organize over 250 events during our time in GDG. This is our fantastic team that brought you this experience. I would like you to give them a warm welcome and thank you, because without them we couldn't have made it. So thank you guys, I really appreciate it, and I hope this was great experience for you. And of course, talking about people who help, we are very thankful for our community partners, because community is all we care about. So building that is really important for us. We also had a great help for our media partners. So Judge IT, Segfault, for programmers, Android Compile, and Programmista Magazine, thank you very much for sharing a word about our conference. We also had help from a few sponsors. One of them was Droids on Roids, a mobile app company from Wrocław that is really engaged in local communities, and JetBrains, who sponsored free licenses for the products for people who will be attending our conference. But our ultimate sponsor is GFT. It's also a company that specializes in very interesting cloud projects. And this really the people you call when you have really hard time to figure out your cloud infrastructure, your mobile infrastructure, anything that they can do everything. So thank you very much, GFD, for sponsoring this event. And as I said, there's a giveaway, free personal subscription for 1 year for people who RSVP'd in our GG community platform in our event. So if you hadn't done that, that's a great moment to do it.
Hello everyone, welcome to the Cloud track at Devfest Poland this year. I'll be your host in the next 2 hours, so let's please welcome warmly our next speaker, Maciej Treder. Let me just add him.
Hi.
He'll be talking with his awesome presentation, What the F is JWT? So Maciej, please.
Yeah, sure. Let's go ahead with that. So as has been already mentioned, my name is Maciej Treder. This is my handle. You can find me on all of those social networks, which logotypes you can see right now. On my daily basis, I'm working in Akamai Technologies. It's a content delivery network, the company based in Cambridge, Massachusetts, and in Poland, we've got a huge office in Krakow. It's the biggest office outside of the United States. And as has been said, the today's topic is what the hell is JWT? So first of all, this presentation is available for you offline. You can find it on my speaker deck. You can also scan the QR code, which you can see right now. And if you don't have time to scan it right now, no worries. I'm going to show exactly same QR code at the very end of the presentation for those who does not have their mobile phones with them. So to the point, before I will answer the question, what is JWT, I would kindly ask you to close your eyes and get back in your memories to the school time. So this is our classroom where children are sitting around. Those are our actors. On the very left, we have a Bob. On the very right, we have a Kate. And inside, we've got a bad guy whose name is Peter. And he is going to act as a man in the middle in our scenario. So Bob is going to write some message to Kate and pass it along his friends. So he is writing it, putting it into the envelope, sending it over, asking his friends to pass this message across. And finally, the message meets the bad guy, who changes the content of this message because he wants to make some mess in the communication. And this is how disaster occurs, because Kate becomes angry when she reads that. Bob, of course, starts to crying, as small boys used to do. And the problem begins. They need to somehow solve this situation. So Bob and Kate decided to use a cipher to share between them a key, which they are going to use to cipher their messages, to encrypt their messages and decrypt them. And this is what we are calling in IT technology the symmetric ciphers. So when the same key is used for encrypt and decrypt the message. Using such cipher, very simple one, the message "I like you" becomes the string or the set of numbers which are hard to guess by a man in the middle. But if the man in the middle would compromise this key, he would be in the communication when the key is exchanged between the parts of the communication. Then he is able to as well read the messages and produce them. So he still can mess up the communication and act as a typical man in the middle. This is how we are leading to the asymmetric ciphers. So that's the place where we have the pair of keys, the private and public key. One is used to decrypting, one is used for encrypting messages. In fact, they can be used interchangeably. So the name private public is not tightly coupled with the file itself. What you need just to mention, to remember, is that when you are sharing the one key from the pair, you should keep the second one private. And those keys are produced using the one-way function. The one-way function is a function which is can be easily computed when you know what are the factors, but it's hard to guess what numbers has produced the function output once you obtain that output. So, for example, multiplying primes by themselves is an example of such function. To generate the RSA key, which is an example of the private public key pair, you need to first pick up such primes, because RSA is based on one-way function which uses the primes. Then you are calculating the one-way function output, which will be our modulus. So this is the number of characters that we can use in our cipher. In this case, we got 33. We choose the small numbers to make the calculation easier, but in real life you will use much higher numbers. Once we have modulus, we are calculating the function phi, which we will use to calculate the exponents. So our first exponent is a number which is relatively prime to phi, and relatively prime means that the phi and e have one greatest common factor, which is of course 1. Then we need to calculate the second exponent, which we call d in this example. You can do that by solving the equation e multiplied by d minus 1 modulus phi is equal 0, which in fact leads us to something like that. And modulus, when you want to put it on the other side of the equation, you just say that the left side is one of the multiplications by 20 of some right side. So we need to choose some n, put it into our equation, and this is what leads us to d equal 7. So now we have the modulus, two exponents, so we can build up the public and private key, which you can see right now. So when Bob and Kate want to use the asymmetric cipher, as I said, they are exchanging just one key with each other, or saying that differently, each of them share one key. So in fact, we are sharing two keys, but they are keeping their private keys secret. And now when they are going to produce message and encrypt message and encrypt the messages, they are using one key for encryption and another key for decryption. So the cipher is still hard to be broken by the attacker. But what happens if attacker will compromise the communication of the key exchange? Now he is in possess only of the public keys. So he is able to produce messages, he is able to write them and encrypt them, but he is not able to decrypt messages. So he don't know what the other part is saying to the second part of the communication. Of course, when the public key is compromised, then the attacker got an information about the modulus, so maybe he would be able to make a reverse engineering and find out what are the factors which produce such modulus. But as I said, in real life, you are going to use much higher prime numbers, and what you can see right now is an example of key which have modulus of 1024 bits size, and this is a really big number, which is really hard to guess and take a lot of time to compute using the brute force algorithm to find out what are the primes which produced this modulus. But still, the attacker, the man in the middle, is able to produce messages. So how to solve this issue? This is what led us to signing. This is a way of proving who is the author of the message. And this is a very crucial technique in terms taking a JWT in consideration. So when you want to sign a message, first of all, you of course need to write it. Then you are producing the hash of this message, encrypting your message using the private key, as you have done with the previous example. Then we are combining message together with the with the encrypted hash, and encrypt that all together using the public key which we got from the second part of the communication. Now, whenever someone wants to verify the message, he of course needs to receive it, then decrypt using private key which he possesses, and he gets an original message and the encrypted hash. So he can hash the original message, decrypt received hash, and compare those hashes and check if they match. So this is how we are using the public and private key together. And what you need to remember is that private key has been never ever exchanged, so there is no chance that it will leak during the handshake. Another way of signing, and another example, is where we've got one person like King who want to broadcast his message to multiple peoples, like citizens in the kingdom, which is many of. So of course King is not asking everyone to create the pair of keys and collect the bunch of public keys from their citizens, so he is going to produce a message for each of them. What King is doing, and what you know from history, that when King wants to prove that he is an author of the announcement, he is just using the stamp, putting it on the letter, and that says that this letter is legit. This is exactly what we are doing in IT as well. So the King is producing his pair of keys, use his private key to sign the not encrypted, the plain text announcement, and share his public key with everyone who is interested in to be able to prove that the signature has been generated using King's private key. The process looks like that. First of all, Kings create an announcement, then he hash this announcement and encrypt the hash using his private key, combine that all together, and this is what he's broadcasting, this is what he's publishing. And now whenever the citizens reads the announcement, he can of course read it, and he's interested in, he can hash this announcement, decrypt the signature which he saw on the official one, and compare those hashes to check if nobody has changed the content of this announcement. And that's flow, this way of exchanging the information in plain text together with the signature which proves that message is intact, is what most people call JWT. But in fact, this is the JSON Web Signature. So the string which you are meeting probably really often when you are working with microservices or any other distributed systems. If you would try to just decode this script, this string using the base 64, you will get a plain text together with encrypted signature. This plain text is built of the Jose header, where Jose stands for the JavaScript object signing and encryption. This is the name of the IETF working group, which works on standardizing the representation and integrity protection of data using JSON structures. The second part is a payload. This is the body, where often you can find a message which someone wants to share with you, or you want to share this message with the others. Finally, we've got that encrypted signature, which is header and body combined together and encrypted. So this is just a way of signing the message. So what is JWT in fact? First of all, JWT doesn't exist itself. JWT, you could think about it if you are a Java-based person or any other, or you are using any other language where abstract classes or protocols interfaces are used. You could think about JWT as an interface which have multiple implementations. One of those implementation is JSON Web Signature. Another implementation is JSON Web Encryption. And we are going to cover deeply what most people call JWT. And this is so these terms in fact can be used interchangeably, so JWS and JWT. And since now I'm going to use the term JWT, and I will have the JSON web signature in mind, so something what example you saw in previous slide. So to the point, as you saw previously, the signatures or the JSON web token is built up of the JSON objects, and those JSON objects, each entry of this object is called claim. In JSON web token, we have the registered claims, like the information about what algorithm is going to be used to produce the signature, what is the type of the token, who is the issuer, for who the token is created, about who the token is created. Then we have the audience, so for who the token is created, when, before which time it shouldn't be used, when the token expires, and you can also assign the unique identifier to the token if you would like to use the single-use tokens in your systems. But registered claims is one part of claims. We got a second group, which is called custom claims, and those are divided into two parts. First of all, we've got private claims. Or let me say it this way, custom claim can use any name that you would like to. And now you have two paths which you could choose. You can go with public claims. So when you are building the system which is going to be used by others, by the third parties, and you don't know who those third parties are going to be, you can register your claim with the IANA JSON Web Token Registry to avoid the name collisions across the world. But if you are using your token internally, or you got an agreement with the third party, what claims are you using, you are completely free and okay to go on with private claims, and that's the often way people choose, because registering the claim as a public claim costs you money. So that's the really not often choose the path. Let's go to some real-life examples when you can use JSON Web Token. So the first example which I prepared for you is an authorization. So before JWT, when we had a microservices environment where we have the authorization service, we have a booking gate service, the booking service, the gate service, and the flight service. The flow of the authorization and communicating in such environment was something like that. So first of all, our actor was sending the post to the authorization service with his login name and password, obtain his user ID, probably that, and in most cases, that ID was encrypted using the private key cryptography. Then the user were sending the post request to the different services in the system, and each of these microservices were asking the authorization service if this user is able to have a privilege to perform action that he's trying to perform. So that was some redundant communication. Later, some people start to put public keys on the services, so service could decrypt the information sent, for example, in cookie or header, but it's and do not communicate with the authorization server. He could read some information about privileges sent by user, but still decrypting every token on every request is a time-consuming operation. So JWT can help here because let's take a look at this flow one more time, but using JSON Web Token. So the user gets his token, which is written in plain text, and sign it using the private key. Now the services can first take a look if there is a privilege in the token, and if it is there, this is the moment when they are incorporating the time-consuming operation of encryption, decryption, and verifying signature. I prepared for you an example of such verification in the Spring framework for Java. So whenever our user posts a request to the ChangeGate service, the ChangeGate service looks for the token inside the request header, then it decodes the token. This is not a time-consuming operation. This is a really quick one. And if token have the privilege, which you can see right now, right here, if the user has the privilege, that's the moment where we are verifying the signature. And if both of those are passed, we are performing the action which user requested. In other case, we are throwing an exception which is handled somewhere else in the application and responds to the user with 403 or 401 or any other error which you would like to. Moreover, if you've got a load balancer in your architecture, in your microservice architecture, you could assign the task of verifying the claimant signature to the load balancer, and the whole process can be done in one instance. So you will offload the traffic in your microservices. Another big pros is that, like using load balancer, you can delegate the process of verifying and validating tokens to third parties like Akamai. So in Akamai, we've got a product which is called the API Gateway, and this is where you can Akamize, put onto our content delivery network your APIs and ask us to validate your JSON Web Tokens. So you can set up a validation for each particular endpoint and tell us how we should validate tokens which are sent to this endpoint. For further reading, I strongly recommend you the article by my friend from Akamai, Jeff Costa, who wrote about JSON Web Token validation at Akamai. You could also go forward with one of my posts on Twilio Voices about protecting and building the example of JavaScript microservices using Node.js and JWT. Let's move to the second example of where JWT is used or might be used. So the OAuth authorization, something what has been created with simplicity in mind, but finally guide us to that whenever I see this something like that, I'm asking myself a question: which system I use to register here? And I am trying each one by one. So something what was about simplified our life, but in some cases it making it more complicated. But let's take a look how OAuth works. Right now we have three actors. On the very left we have an application, the third-party application. Let's say it's our mobile app on the mobile device. Then we have the two parts of another organization. We have the authorization service and the resource service. So let's imagine that we have an application which requests for the pictures for our pictures from the Facebook service. So first of all, this application needs to authenticate against the authorization service. Once this is done and user grants access, we get an access token in exchange. This is the token which we are using while we are communicating with the resource service and request for the pictures which we want to obtain. The resource service then asks the authorization service if this token is valid, if it is okay, if this is given by you. Then the authorization server responds, and once the resource server gets that confirmation, he can respond with the resource to the requester. But if you would use the JSON Web Token as an access token, we could get rid of the communication between resource server and authorization server, similarly as we had in the previous examples. Thanks to that, we are making the system a little bit faster and more efficient. So that's all about JWT. Let's move to a second part which I prepared for today. So the another term which is around JSON Web Tokens, and this term is JSON Web Key Set, JWKS. So this is the system which answers the questions like, what if I will lose my key? What if someone will steal it? What if I want to invalidate someone's access? So I give someone a token, and once he has that token, I want to invalidate his access because of any reasons. For example, token has get compromised. So this is where we've got a repository of public keys which should be used to validate tokens. And this is the panacea for the pains which you can see right now on the screen. How JSON Web Key Set works. First of all, the actor asks for a token from the authorization service as he did before, and he gets this token. But this token has two additional fields which the previous examples didn't contain. And those key fields are JKU, which stands for the JSON Web Key Set URL, so the link to the keys repository, and the key ID, so information about which key should be used to validate this token signature. Now, whenever our actor asks the booking service or any other service to perform some action, this service, when it checks if the token contains the claim which should be there and want to verify the signature, goes to the URL specified in JKU claim, fetches the key with the proper key ID, and uses this key to validate the signature. Thanks to that, for example, when we want to invalidate access, we are just making the rotation of key with ID 12, so the key which will be fetched by the service will no longer verify the signature. How the keys are kept in JWKS. So they are kept in the similar way as JSON Web Token looks like. So this is just a JSON representation. You've got an array of objects. Each of them have entry which says what is the key type, of course, what is the key ID, for what algorithm it should be used, where it should be used, if it is used with the signature or for JSON Web Encryption, so for the whole token. What is the exponent? This is the information which at the very beginning, if you will recall the example where we were calculating the key pairs, we were calculating the exponent used for generating cipher. Finally, what is the modulus? So this is that big number, the output of the one-way function. And the other information, a part of standard attributes, which I showed you right now, you can, for keeping JSON Web Key Set, also the private keys. So, for example, you can keep information about the certificate chain or the Chinese reminder algorithm parts. So information that is needed for the Chinese reminder algorithm, like the P and Q primes or any other information relating to the key. Let's take a look one more time, step by step, how the JWKS can protect you against bad guys. So let's consider the situation when the attacker compromised the private key. Somehow the private key has leaked, so attacker can produce and sign the tokens for himself. Whenever you will see that such situation occurs, you are just rotating the keys in your JWKS. So now whenever attacker sends the token and the token asks for this particular key ID, he gets a public key the service gets a public key which does not correspond to the private key which has leaked, so attacker does not get an access to the system. So that's all about JWT and JWKS which I prepared for today. Let's go quickly through pitfall and vulnerabilities, which will summarize the information which we obtained so far. So first of all, the thing which you need to remember about the data security. JSON Web Signature, which is often called JSON Web Token, is not a place for keeping a sensitive data like personal ID numbers, credit card numbers, social security, and so on. Those tokens are just encoded, and the information inside token can be read by anyone, like in the King announcement example. The JSON Web Token is only a way of proving that the information about the information integrity. The second thing is that you should never ever validate your token using the information which is inside the token. You should also embed your token validation logic inside your program. Do not trust any token that comes to you and what it is saying. The reason is that the algorithm known that's saying putting the claim which says that there is no algorithm used for signing is a completely okay and completely valid token. So if you won't check what claims are inside, and if algorithm is specified as it should be, then you could implement logic which passes the validation of such prepared token and grants someone's unprivileged access. Another thing which you should consider whenever you build any system, and JSON Web Tokens are not the it's not the difference here. You need to pay attention on what you are printing in the error messages. One of the implementations of JSON Web Tokens in .NET were printing what should be the signature of token which you passed. So an attacker could pass the token with any signature and get an information what he should put as a signature in the next request which he will send. Next, you need to remember to follow guidelines from the key specifications. So don't use short keys because they are going to be vulnerable for attacks. What you also need to remember is decoding is not verifying. So you should, whenever you see that the claim is in token, it doesn't mean it should be there. You still need to verify the signature. You could think about the JSON Web Token as a hashcode method in Java or other programming languages where you have the implementation of hash map or hash sets. So hashcode is used to verify. You can with 100% sure say that two objects are not equal if they have different hash codes. But if they have same hash code, you still need to verify their equality using equals method. The same applies to JSON Web Token. If the token does not include the claim, there you can for sure abandon the action and do not go forward with any other actions. But if claim is there, you need to still verify the signature to make sure that this claim should be in this token. Another thing which tokens are vulnerable is called the time attack. So this is where an attacker is trying to guess byte by byte what should be the signature of given token. And he is verifying if the common going on bytes are set properly by measuring the error response time. So how much time takes system to verify next bytes of signature. Last but not least, as far as I remember, my favorite kind of attack. So remember to always verify the URL provided in the JKU claim. Let's consider the situation when attacker built his own JSON web key set, and this is where what he puts into the claim, the attacker com JSON web key set.json. So system would go to this particular JWKS to get the public key and grant attacker an access. This is the reason why in Akamai, if you are Akamaiing your API and you ask Akamai to validate JSON Web Tokens, and you say us that we should use JSON Web Key Set to get the public keys from, we are always asking you what are the JSON Web Key hosts which we should trust. So we are validating if attacker did not manipulate, did not publish his own JWK host. Summarizing, JWT, as we said, is often misused, confused with JSON Web Signature, and those terms are used interchangeably. It's a way of sharing the data in the stateless manner and proving who is the author of the data, who is the issuer, and proving the data integrity. It's built up from the header, payload, and signature. Remember to do not keep the sensitive data inside tokens. That's a place for information like what are your privileges in the system, how many points you've got in the program, and so on. But it's not a place for credit card numbers, social security, and so on. Always follow the best practices for the algorithm which you choose to signing the tokens. And finally, if you need a way to share the sensitive information, you should probably consider JSON Web Encryption. At the very end, I would like to share with you some resources. So first of all, the information which I shared previously, so how the JSON Web Token validation works at Akamai. This is written by my colleague. How to verify JSON Web Tokens using JWKS, the RFC, of course, the documentation, and some resources from my end. So the set of the articles on how to build an example of microservices, communicate between them, and incorporate JWT and Twilio Authy for authentication and putting into your system some protected microservices. Last but not least, I would kindly ask you for the feedback on this presentation. I would really appreciate it. If more bad you can write, it's better for me because I will have something what I could learn from. So I would be very, very pleased. And as I said at the very beginning, one more time, I'm sharing with you the QR code to the presentation in my speaker deck, where you can find all of the links and you can follow it offline afterwards. So let me keep this slide for 15 seconds between I move to the last one. And at the very end, you can find me on Twitter, Medium, GitHub, LinkedIn, anywhere under the same handle, which is my first name and surname together, without any dot or any other separator. That's all from my side, and thank you for your time.
Mike, thank you very much, Maciej. As I said before, this was an awesome, really presentation. Thank you very much. And going for next speaker in our cloud track at the Devfest Poland 2020. Let me introduce you to Maciej Hyzy with the presentation, Introduction to Apache Airflow and Cloud Composer. Let me just click him through, and here we are. Hi, Maciej.
Yeah, Piotr. So
sorry, Piotr.
Don't worry.
Yeah,
that's fine.
Let me just show the stream, and I'm.
So thank you very much. Let me start the screen sharing session. Wow. Yeah. Okay. So thank you very much, and welcome everybody on today's session, which is a part of Devfest 2020, and I'm to make the lecture about the introduction to Apache Airflow and Cloud Composer. This is a really wide topic, and because of time constraint, my intention is to give you an overview what the Apache Airflow is, how you can use it, how Google helps you with the Cloud Composer, which is the Apache Airflow as a service on a GCP platform, plus a small demo, which will be really small because of the constraints, time constraints we have. So let's start with introducing myself. So my name is Piotr Hyzy. I'm a cloud architect at Anthos Poland R&D. I have been working for Anthos for almost 8 years for now. Right now I'm part of a strategic partnership between Anthos and Google, and mainly involved with development of BMS, which is the bare metal service, which is available on GCP. Probably you don't know this service, as its availability it's limited to a group of enterprise customers. However, probably in nearest future it will be widely available on the platform. Next to that, I'm open source passionate and one of founders of OpenStack Competency Center, which running at Anthos Bydgoszcz. And privately, I'm enduro biker, bike rider, and mountain hiker. So you can meet me at Anthos office at Bydgoszcz or at Tatra Mountains, where I'm really often. So today's session is about Apache Airflow. And I would like to limit theory about that and mostly focus on a source code examples. Then we'll talk about the Cloud Composer, which is the great implementation of Airflow as a service, and then we point to the small demo to see the really simple, however, I hope meaningful DAG in action. So, what is the Apache Airflow? This is, we can the Apache Airflow. We should understand it as a tool to manage our workflows. I always prefer name orchestrator because this is my main use case. I'm orchestrating different jobs through the Apache Airflow. However, mostly used on the market, mostly on market is described as a workflow management tool. So when considering the Airflow functionality, we can start with a similarity to cron jobs. However, it's a much more differences because the cron jobs are really flat scheduled task, and the Apache Airflow brings a lot of more functionality. So it's much more rich the scheduler, which allows to make a dependency between a task, between workflows, provide really granular schedules and definitions of these dependencies. The main use cases which makes it which gained the popularity on the world are the data engineering and machine learning, and it's because of Airflow ability to support low running long-running operations. Yeah, so it can easily manage a workflows which run for 5 minutes, but also workflows which run for a few weeks, and that's the one of the powers. However, its functionality is not limited to this. It's from my use case, it's the automation of certain DevOps operations, and here we can, for example, consider is a tool which can manage the, for example, capacity management workflows, where the workflows run periodically, scanning the local infrastructure, I mean the hardware infrastructure, checks about the available resources, and then makes action if, for example, some resources are running out. For example, they may, use some kind of task to make orders to vendors, make waiting for vendors response, may trigger a task which helps translate the natural language of, for example, of written order to a language of computer systems to process the orders further. Then it may trigger another task to generate instructions for on-site operators to install new hardware, then update databases, the CIs, monitoring systems. So we can really define complete and complex workflows and manage them with use the Apache Airflow. So let's go into Apache Airflow language. So the first citizen within the Apache Airflow is a DAG. DAG is a directed acyclic graph, and the DAG is an instance. We can call it the DAG is definition of workflow. So workflow is an instance of DAG. So the DAG gives us a definition of jobs, so tasks which are executed within this DAG. And on the picture, we see the example DAG, which it's not much complex. It isn't complex. However, it gives overview how it may looks like. So it's the composition of tasks, of dependencies between these tasks. The DAG is defined also by schedule. So with the schedule of the whole DAG, the start date, end date, some date dependencies, task dependencies between tasks, and then the dependencies between tasks can be, for example, the one task may based on the past task success or failure, or other task status, or certain condition, which in fact can be everything, because Apache Airflow is written in Python, and it accepts a task definition written in pure Python. So the task definition is as much flexible as Python is flexible. So, sky is the limit here with defining the logic. So let's look on DAG from a source code side. So the DAG is an instance of DAG object. So workflow is instance of DAG object. This is a simple DAG definition. This DAG has no tasks right now, so it's just a framework for where we can add the tasks future. So it's defined as a Python script. So you see, we import Airflow. From Airflow, we import the DAG object, and then we define the DAG. This is the simplest definition ever. So we just the DAG name. It's the default arguments. The default arguments are quite nice thing, because they are passed to every let's say nested object like tasks. However, they can be controlled in the granular way on each task level. So we may change this dict of the parameters. Of course, it's just example, because there is much more parameters available. So the documentation of DAGs is available here. So it's on the Apache Airflow site. It's a really comprehensive documentation. And the DAG is used as the context manager. So yeah, it's the one of potential way to use it, but however, it's recommended. So we open the context manager, and then under the context manager, we'll define the other stuff. So another important thing is that the DAGs they have to be defined in the global scope of a Python file, so Python code. If we define the DAG under a local scope, that DAG won't be discovered by Airflow. So in that case, only DAG1 is visible by Airflow. DAG2 is invisible because it's in the local scope. The next thing is the workflow is a DAG instance, and then the workflow consists tasks which are instances of operators. So operator is a definition of a job which is executed, is controlled by a workflow, and the task is instance of this job. Yeah, because each job definition, each operator, each operator, can be used multiple times as multiple task instances. So here we have the example of two very simple and basic operators. However, it shows that the operators may have different scope. So there are very narrow operators which do some specific atomic operation, like, for example, sending email, pushing or pulling an object from storage bucket, making a SQL query to a remote database. However, there are also the very wide operators, like the Python operator, which can be everything, because at the end it points to a Python function. In that example, this is the demo function, which can define almost everything. Yeah, everything what can be defined by Python. So the best practice is to defining our own operators. So the Python operator is mostly used as the last resort, or is used for some quick actions. However, if we need to, the best practices is to write our own operators to have the scalable and portable code between Airflow instances. The next important thing is a definition of dependencies between tasks. And the Airflow uses for that the bit shift operators. There are also the old methods, let's say legacy. However, this one is recommended, and we'll focus on it. So this bit shift, this is the right bit shift operator, defines that the task 2 depends on task 1. So it means it starts its execution once the task 1 is done. It's done. It doesn't mean it's done with success or with failure. Basically, it's done. Of course, we can create more granular rules. It's called the triggered rules, then defined where the task 2 may start execution, whether it's task 1 success or failure. However, this notation is just simple dependency of task 2 on task 1. There is also possible to make some more complex dependencies, like here. Once the task 1 is done, the task 2 and task 3 start executing in parallel. And then if one of them complete, then task 4 start execution. Here are the links. So the Airflow brings some set of built-in operators, which are listed here. So you see a number of the built-in operators. However, there is the huge library of provider operators, and in case of Google, we have a few categories, and in the cloud we have, you see, a lot of operators, and this is just definition. For example, for storage, there is a few operators defined in each file, so it's really huge library of operators which increase the flexibility of the Airflow. So let's drilling down into the lower part of the Airflow architecture. The Airflow is designed as the following the microservice approach, and there is a few key components which I would like to give an overview of them. So it's a database which keeps information about DAGs, task instances, DAG runs. DAG run is a one instance of a workflow which is running. So each workflow may have multiple simultaneous instances running in parallel. And the database, it's from the Airflow perspective, is accessible through SQL Alchemy module. Then is the scheduler. It's a process that schedules the task execution based on their priority. And then there is an executor, which is the key element. So the executor, it's kind of a message queue with the local executors running on worker nodes. And in a simple Airflow implementations, the executor may run on the same node where the scheduler. So in that case, there is the local run or local execution. However, in the production, let's say level implementations, the executors are distributed among a number of worker nodes, which can be servers, virtual machines, or containers. And then we have the workers. So the workers are the nodes where the executor schedules the jobs. And here we need to highlight one important point, because the worker, it can be the place where the code is actually executed. So the task is executed. For example, in case of Python operator, the whole code is not stated differently in the Python code itself. I mean, the task within the code defining the task is executed on that worker node. However, there are operators like Kubernetes pod operator, where the code just initiate on a worker node, and then the execution is moved to external infrastructure. In that case, in case of Kubernetes pod operator, it's created new pod on the same or external Kubernetes cluster, where the job is executed within the predefined image. So yeah, as you see, it's quite complex. It's a few elements which need to be managed, and it's quite complex task to install Airflow on infrastructure. So here, thanks to Google, because Google offers to us the Airflow as a service. This is the Cloud Composer service, which makes the Airflow infrastructure creation and management easy, powerful, and consistent. So the Cloud Composer helps us to create the Airflow environment by one click, yeah, at the end. And we don't need to spend much time on, on this infrastructure management tasks and on thinking how to, plan our infrastructure to run Airflow, on, downloading images, preparing dependencies between the components of the Airflow. Everything is provided out of the shelf. So let's see the advantages of the Cloud Composer. So the one, let's say let's start with the simplicity, because how I mentioned, it's the one click to create a new Airflow environment. We can use all GCP messaging channels or controlling channels like Google SDK, like Cloud SDK, Web UI, or Google API. And we can also easily manage access to Airflow Web UI using the IAP proxy. Cloud Composer brings production level monitoring with the close integration to Stackdriver logging and monitoring, and integration with metrics and alerting of our jobs. So I think this is really a big added value, because it's most topics when we struggling when deploying the production clusters of Airflow. Yeah, and here it brings all the, let's say, monitoring backend of GCP out of the shelf. Python packet management, what is also not trivial, because normally it requires from operators, from administrators, the CI/CD pipelines to update the images of worker nodes every time we want to use in our Airflow DAG definition code a new Python modules. The Cloud Composer also manages this for us. And this integration with the other GCP services, the one area is integration with the set of operators to which can control different or use or leverage different GCP services. From other side, it's the scalability of GCP, which is also available from the Cloud Composer perspective. So let's drill down into how Google design or architectured Airflow to run as part of the Cloud Composer. So we see the Airflow database and Airflow web server. It's moved to separate tenant project, which is managed by Google. So it's not under our visibility. And then within the customer project, it's created dedicated Kubernetes engine, which is which contains the Airflow workers and Airflow schedulers and executors. So from one side, we have the Kubernetes engine and the scalability of Kubernetes engine managed by Cloud Composer. From other side, we receive extra layer of security by hiding database and web access into dedicated tenant project managed by, let's say, Cloud Composer service, in that case by Google. Yeah. It also gives us the elasticity with the managing the DAGs, because the DAGs are running on the DAGs are managed through the cloud, are stored on the cloud storage. So managing a DAGs is as simple as pushing or pulling files from cloud storage. Okay, goes very quickly. So how to create the Cloud Composer? This is the, how I mentioned, all channels possible. This is the one command task. It's the G Cloud Composer environment creates with the mind parameter as the composer environment name, and then few attributes of the environment. Of course, they are not all. It may be more defined in more granular way. The completion is about 1 hour. So it's 30 minutes to 1 hour, depending on the cluster size. It's still a lot of features of Cloud Composer is still in beta. So very often changes afterwards are not possible. So I recommend to use the CI/CD pipelines to rebuild and not update the clusters. And then we move smoothly to demo. So my initial idea was to show something more complex. So I wanted to show a simple microservice architecture where there is a cloud function which is called externally, and then it triggers the Cloud Composer, the workflow execution through the REST call to Cloud Composer, so to Apache Airflow. However, the Murphy law is still alive. I don't know, but it seems that today there was problems with the cloud function, as I couldn't prepare the demo environment at the morning. Also check with my other projects, so my enterprise project and the cloud function. There was an ability to create a new function. So probably it's some why there outage related to the cloud function to creation of new and also update, because it's also not possible. At least it was not possible an hour ago. So today we'll unfortunately only limit to triggering the DAG directly from Cloud Composer UI. However, the code of the cloud function I will share later. It will be available on a Git repo dedicated to this presentation, so you can test it afterwards. So this will be really a simple workflow because of the time constraint. However, I wanted to show a few new things. And I wanted to show how the Cloud Composer works and what you may achieve with it. So firstly, we have the task which is defined by the cloud storage sensor. And this task, the sensor is a kind of operator which waiting for some actions, let's say. And this sensor waits for a file to appear on a storage bucket. So we have a demo Devfest storage bucket, and monitoring, the sensor will monitor the bucket and wait for a new file. We're waiting for specific file which is named Devfest, but it can be configured differently. However, this is quite simple example. Then once this file appear on the bucket, then the task is done and the next task execution starts. So the next task is defined by file transfer operator, which is a really powerful tool to transform files. So we get the file from bucket. So this is the new file appeared to the bucket, and then we make the processing on this file. In our case, the processing will be really simple because we'll copy one-to-one without changes to the file. However, we could do everything what we want with this file. So the file transformation template is defined by a shell argument. So it can be a shell command, but also it can be the script, our predefined script, which is available in the local file system of executor, which accepting two parameters, input file and output file. And then the steps defined in this shell, in the script, it can be any language script depending of the languages available in the container where the executor is running, or the service virtual machine, sorry, where the executor is running. After transformation, so after data processing, the file is stored on the bucket with a new file. So this is the new file, basically, because we don't modify original file, rather we make a copy of file, and when making a copy, make a transformation. So it can be, I don't know, video rendering or other kind of video processing. It can be picture processing, can be text processing, almost everything. And then we have two Python operators which run in parallel after the second task is done. And again, there are very simple code which just print values. However, it's just to see just to show the functionality. So let's go very quickly through the demo code. So we have the cloud storage prefix. And you see that here the bucket is defined by a template variable. And this is another feature of Airflow. So in Airflow, we have a few methods of passing variables or data to task execution. The most simplest ever method is Airflow variables, which we can set through command line or through the composer command line. And then they are available in the tag definition as a template. There are another methods like internal messaging, which is called XCOM. We can also pass data through external databases. However, again, this is a topic for longer discussion. And then it's the Google Cloud default connection, which is defined by Composer. So it's available out of the shelf. So it has the permissions. The composer or the code running on composer has the same permissions as the service account which is used to run the composer. The next task is the transformation. So here also templates and some arguments are provided as strings. And then there's transformation scripts, which is very simple with just CP, so it's the copy. And then third task, so third and fourth, is the Python operators, but here I used a little magic. So the tasks are defined automatically in a loop. So we're looping over two values, 1 and 2, and then create the hello world 1 and hello world 2 task, which points to the same function. And this function is the demo. We just print argument and we pass extra argument, which is the hello world. And you see, we don't define this as a object, but directly use the bit shift operator to make the dependency on the previous task. And let's now switch into the environment. So this is our task, our Airflow environment. This is the Airflow. This is our DAG. This is the previous execution. Yeah, for tasks. Then we have a DAG folder on the bucket. We see this is the built-in monitoring DAG and our DAG, and on the buckets we have also another bucket, which is called demo Devfest. Which is right now it's empty. So let's run this DAG. We may pass extra parameters. Let me do this. Let's say key 1. If we would trigger this through the cloud function, through the API, this will be parameters defined in a body of the request, and then trigger. It's queuing. Now it's running. So it may run forever, or how long we defined the DAG may running. So 1 day or 1 month, and wait for the file. Yeah. So let's push the file to the bucket. The bucket is empty. I push the file to bucket. We see the file appeared. The file sensor requires a while because it's pulling every some period of time. I think it's 20 seconds or 30. It's done, you see. So it discovered the file. Now we start the transform file task. This task will pull the object transform in the local on the local executor, and then push back to this bucket. Of course, we could push back, for example, to S3 bucket on AWS. Yeah, the same way. It's done. So we may observe here. Yeah, then the new file is here. So it's the file pushed by. And we see the tasks are hello world are done. We can look into the log. We see there is a hello world message. And also we see the values we pass it to the DAG at the begin, they are available within the Python code execution as a dict of arguments. Yeah, so we paste the one key 1 with the value 1. However, this open a lot of doors, because we can do, we can control we may parameterize the DAG execution by passing the input parameters manually through the web UI, but mostly this is passed by other services which trigger the DAG's workflows. Yeah, and it's done. Yeah, it's success. Yeah. Okay. I think I'm a little bit out of the time. So thank you very much for attending, and looking for feedback. The email, sorry, I missed the last page of the presentation. However, the presentation will be available later. So there is my contact details, and looking for a feedback about the presentation. And if you have any questions about the Apache Airflow, then don't hesitate, and open for discussion. Thank you very much.
Okay. Thank you very much, Piotr. So we have like 4 minutes left. Remember that you can also comment on our YouTube channel, on the stream channel. Also, remember that if you have any questions in the future, you can also try to ping us via Facebook and other channels. So we'll ping Piotr next, and he will respond to you about his topic. Okay, we have still 4 minutes left. So Piotr, thank you very much.
Thank you.
And let's take a short break and see you back in a few minutes. And we're back. Okay, so let me add our new speakers. For now, let's see our faces only. Hi guys, thank you very much for coming, Konrad and Kamil. Welcome to the Devfest 2020. You are from the GFT company, right?
Yes, we are from GFT Poland. Kamil Kłys is an open banking specialist and backend developer, and I'm front-end developer.
Awesome. Thank you very much. Okay, the stage is yours. I will just add the stream and focus on it. So thank you very much. And
right. So as I said, Kamil is backend dev and I'm front-end dev, and there is some connection needed between our worlds. So that's why we are going to demonstrate you one of the most interesting capabilities of Apigee Edge, one of the Google's API products, fully managed. It's an API manager and gateway at the same time. And if you look at this from the simplest perspective, from the simple use case, this API manager can serve as an API proxy in your, for example, Google Cloud between a client and the underlying backend services. Let me show you how it looks like in the control panel. So there is this dashboard of the manager. We have some proxies, and we have some geofence proxy for the beginning. Here, let's go to the Develop tab. One of the best features I found in Apigee Edge is that it can use plugins, or it's so-called plugins. They are called policies that you attach to your message going from the end user or app to the backend, and modify this message and modify the whole flow. There are 4 basic flows: pre-post flows for proxy endpoint and target endpoints. Here it's how it looks like. So at each step, you can do something with the payload, or you can do something with the flow, for example, throw an error if something is not going in a perfect way, let's say. There is also this post client flow used for logging. All right, and we had the simple scenario. Now let's have this scenario a little bit expanded. Suppose we want to add some geofencing policy to our proxy, which is run on the proxy, so with 0 latency. And imagine we have some countries in which we want to sell our services, and some countries that we don't have agreements, for example, to sell our services to. So this geofencing policy will check the IP of the user, and then check the country he or she is coming from. And yeah, let's look at the policy right now. So I created this simple JavaScript policy. As you know, I'm JavaScript developer, front-end dev. So please don't judge my JavaScript skills by this code, but let me explain this in short to you, what's going on. So here we have some input, and we call some, in this case, external service to check the country of the user. And if it is, in this case, in Germany, we can see this. Now let's change our country. Let's say it's Anguilla. Okay, so as you can see, the access is denied, and there is some custom message, of course. This sad guy tells us we cannot access the data from this proxy. I added this to the target endpoint response pre-flow, so at the very beginning. All right. This is one of the scenarios, and we have more of them. What's very good about Apigee Edge is that it has extensions to use cloud services directly. So if you, for example, create some cloud function and want to connect to it not by URL but using service account, you can also do that. So in next scenario, I will show you how the client connects to the proxy. The proxy gets some data from the backend, and it will also give you some more information based on the cloud function that it has called. For this purpose, I created a cloud function on my Google account. The source is very simple. So when it has some message from the input, it shows this message. Otherwise, it returns this message. Otherwise, it says, hello, cloud function world. I also created a service account with cloud function invoker role attached to it. Let's go to this proxy. I'll show you how it looks like under the hood. It's also very simple. So at the beginning, I've created extension callout policy that calls our extension, which I'll also show you. This is the Google Cloud Function Connector. It's using region US Central 1 project ID sandbox on my Google Cloud. It's using this function name you've seen, method post, and it's providing message hello from Google Cloud Function, not from Cloud Function World. So let's have a look. This is a proxy to many endpoints, so I just pass to lists. Oops. It worked a minute before. List. All right. And you can see the same response that was here before the sad guy came, but with some extra data. This extra data is from hello Google Cloud Function attached to this Cloud Function response key, and these our partners from GFT Spain mock. Yeah, these keys can also be, of course, created with another policy that's assign message policy. So you can see that when I have this flow, I call the Google function first, and then I call this assign message policy to modify the response with the data that came from the base path, let's say, and the function response. All right, and another policy that I've prepared in order to show you how we can manage data from cloud is Cloud Firebase. And for this purpose, the flow will be very similar. So we will get some data from the Firebase. Let me show you. So I created some Firestore. I created some Firebase console. It's worth mentioning that you should also toggle this real-time database in order to get the URL, but it is using a service account to connect. And here's the data I've prepared in Firestore. Same goes here. So you can see it's on cloud. Let's look at the Firebase proxy. I also added some course headers. And like with Cloud Functions, I'm also calling extension. This time it's Firebase extension. They are added in extensions, admin panel. So you see here Cloud Function, Firestore, PubSub, which actually isn't deployed yet. And yeah, what's worth mentioning, you provide your service account credentials here. Good. Let's go back to the proxy itself. Let me show you how to connect to Firebase using this extension policy created in the admin panel. So we are getting Firebase data. Again, this policy is very simple because we are using extras column, and I'm fetching document which is called extra PD Firebase. Yep, extra PD Firebase. When I get the response, I use assign message policy again. So I attach the response to the variable Firebase. I tell you more about the variables as well. And then there is also this policy to add some course headers. All right. Firebase list uses the list data from our partners. But as you can see, there is this Firebase response with the whole data from fetched from the Firebase document. So it's hello, this is Cloud Firestore, yeah, and some special value. The variables are some things that can be attached to the context object. In Apigee, you have some basic variables, so like reserved keywords that give you information about the client IP agent, etc., that give you information about the proxy itself, which is especially useful when you use, for example, Apigee hybrid version of Apigee. That's the sister of Apigee Edge, but you can deploy it somewhere in your GKE and anywhere actually in the cloud if you have Anthos. And yeah, it's got the proxy ID information, client information, API information, target information, and also you can add some variables here, just anything you wish. So I think that's more or less it. Kamil, would you like to show us your part?
Sure. Let me share my screen. Okay, can you see it? Okay. Yeah, so what Konrad showed you so far are how to connect the proxies created in Apigee with some cloud or even external services. What I'd like to show you is a little bit of a showcase what the Apigee can give you and how to develop purely in the API proxy with the set of predefined and just available proxy policies that are configurable, and basically they give you a lot of flexibility and lets you achieve something that without Apigee or any other API manager with such capabilities would require you to actually code something on the backend services or some middle layer. So yeah, let me jump into the presentation and show you what we'll be talking about in the next few minutes and how it is implemented. So in this example that I will show you, I implemented a simple use case when the client wants to consume the backend, but it was required that some changes are being done between the client call and the backend, as well as some post-processing after the backend response is received. So in this example that I will show you in details in a few seconds, what we will see such flow. So the client consuming the API through the Apigee proxy his call will be processed by a few of the policies, and those are like retrieving some values from something called key value map. I will describe it to you in the details in few minutes. Then we log the request to the third-party service, and for this one I simply use the Logily, which is the third-party logging service. We'll verify some quota policy. I will tell you about it in a second as well. We will make a verification on the authorization using a simple OAuth protocol. Then we will remove some headers related to this authorization, not to compromise the user. Then we will use a cache policy. Depending on the timeout on the cache, the response will be immediately returned from the cache, or it will be directed to the backend. We will do some transformation from XML to JSON. So, these days, I think it's getting more and more popular that the format of the messages between the clients and servers is JSON. But for the sake of this exercise, I decided that client that talks to the backend speaks only in XML. So just to show you this policy of the transformation. Then we will do some simple verification on JSON schema to verify if the request matches given policies. Then we will do some simple modification on the request. And all of that we did before the request even reached the backend. So then when the message reaches the backend, in parallel, we will log the response to this third-party service. So the Logly service that you saw. We will transform the backend response back to XML. So to the format supported by the client. We will do some short modification on the response, and this response will be visible to the user. So now let me jump into the Apigee to show you how all of that is being done within the proxy itself. So for this one, I created a simple API proxy called Social Media API Demo. And if I go in, you will see those screens that Konrad already showed you, but this time I will deep dive into the available policies. So I go to the Develop tab, and you can see how easy is that to build your API proxy with just the blocks, right? So all of those schemas that you've seen are basically now reflected in those blocks in here. So those are all the blocks, all the policies that I showed you in the screen. They are now implemented here in API proxy. So the policies can be chosen from a number of available Apigee proxies, which basically deliver you the basic functionality, but all of them are very flexible, and I really encourage you to look into the documentation if you are interested on how you can use them for different purposes. So a quick look into what can be done. So the first one is this key value map operation. So basically, this one allows us to retrieve some custom variables that are available in the environment itself, so in the API proxy environment. I needed that variable because in order to perform an action on the second policy, which is logging to external service, I needed to provide some API key. So I didn't want to put that information directly in here, although I could, but I decided to use this key value map. So key value maps are very straightforward to use. So you can access them from the same UI. So we have key value maps in here. So you will see in a second, I hope, how they are configured. And basically, the structure is very, very simple. And this is something that you would be easily get familiar with. So I have this key value map called variables private. I called it private because it's encrypted. So as you can see here, I'm not able to see the value. But this retrieval mechanism of the key value map policy allows you to read the private messages and have access to the actual variables. So with this key defined, let's jump back to the proxy. And I will quickly show you how this value is retrieved, which is very, very straightforward and simple. And then how it's used in the further processing. So in order to retrieve the value from that key value map, the only thing that I need to do is to actually give the map identifier. So it's just the name of this map that you just seen. And then as simple as providing a piece of XML that will basically tell which value from that key value map to take and where to store it. So assign it in the proxy message context. I use the private keyword, so the private suffix, telling Apigee that this one is an encrypted property, so it will know what to do with this value. So it will retrieve it properly, and it will be available for the further processing. So this is how I do it. So then, very simple policy. So if you know Logly, then you know that it's just a simple third-party logs collector. Obviously, you can use any other tool here that will give you a possibility to log to the external third-party service. So Logly has a really straightforward API. So for that API to work, I needed to provide this private key that will give me access to the Logly, and then I just put a piece of information that I want to be visible in the logs. So Konrad showed you that we have some variables available, so like organization, API proxy, environment, and some other flow-related values like request. So you simply operate on those properties, and you can retrieve the values using this simple syntax. So all of those values will be changed into the actual values when we see them in the Logly, which I will show in a second. So then a very simple quota policy. Basically, this one can be used. For example, imagine the scenario that you have your backend, which for some reason is not able to process given number of requests because it's slow or there is any other kind of business reason. So you don't have to secure it on the backend itself. You can do it on proxy. So in this example, I gave a pretty big quota, I would say, at least for this exercise. So I configured in this way that within a time of 5 minutes, so this is the value here 5, this is the time unit of minute, it means that I can do the 50 requests per 5 minutes in this proxy. And I will modify that policy later on, so you can see how we are protected just by the proxy. Okay, then there is a very simple policy. This is a built-in standard in Apigee. So we just verify the OAuth to access token, and without the proper token, our call is being rejected. Then, as I said, for the sake of the security reasons, so for example, this API proxy key is not being directed to the backend because it was originally issued by the consumer. We simply remove this header. So it will disappear as it is no longer needed in this proxy policy. Then you have a simple cache. Basically, this one is, as you might already guess, to cache the responses, so we save on the time, basically. There are also several rules on which you can define the cache. So for this one, I use a very simple rule. So the cache times out after 5 seconds. So if I make succeeding calls within the time of 5 seconds, then you can expect that at least some of them will be delivered directly from the cache without even touching the backend. Obviously, you can decide based on what information you build the key for the cache. For me, it's just a simple request.uri. Then, as I told you, just to showcase this particular implementation of the proxy policy, we can easily transform a message to another format. So for this one, I use XML to JSON policy, sorry. That basically simply transforms XML to JSON. There are some options. So for example, I wanted to skip the root element of the XML. So I use this strip level property that basically does the trick. Then we can employ some policies for the validation of the requests. I don't know if this is very common, but I can imagine some scenarios that when you want to protect your API in this way. So here you can decide what are the policies and basically limitations that you can put on top of your API proxy and any request that comes in there. So for example, something that I will try to show you in a few minutes is that you can, for example, change this value of object entry count, which means that basically we have a limit on this particular property of the JSON schema. Then a very simple showcase on how can you modify the request. So in this particular scenario, I'm just playing with the headers. So for example, I'm removing some custom headers, some custom query params, some form params as well, but then also adding the new headers like mediator where I put Apigee. So for example, it could be used for the backend to verify actually who was the originator or the middle layer between the client and the backend. And I'm also overriding some headers. In my case, I'm overriding accept encoding to gzip and deflet. This is what happens with the incoming request. So this is when it hits the it hits the backend, and when the message comes back, I do a few kind of other simple policies. So I transform JSON back to XML because I told you my client, in theory, speaks XML only. So I use this simple policy that I can obviously modify, and then I do some other modification, just similar to the previous one with the proxy, with the message headers. In addition, I have it in the post flow, so basically it doesn't. It's not included in the main flow, so it doesn't influence the overall proxy performance. I'm logging the response in this logly third-party service using the same policy. So it's just more or less the copy paste of the previous policy, although it shows us a little bit different information about the response status and response body. Okay, so let's jump into the example. In the meanwhile, I will show you also a very useful feature of Apigee. So for every proxy, you can run a trace. Trace basically gives you a possibility to track any incoming request to the proxy. So when we start the trace session, now it records all the incoming requests and will show me all the details that I might be interested in. So when I run this example, you will see a different processing that I will go through in a few seconds. Okay, so let's imagine I have this API here. So this is my I'm calling this API proxy. So you can see it's Apigee social media app API demo /posts. That is my endpoint that I want to call, and I'm calling with some simple dummy XML request. So if I try to send it, it's possible that you will see an error message. No, you didn't, because my token didn't expire yet. I will show you that in a second. So you can see that I got a successful response, and let's see what happens. What's happening is here. I think in a second it will show us. Sorry, I ran the trace session on the wrong environment. Let me run it on test and repeat. So in a few seconds, we should see it. Yeah, so you can see that Apigee proxy recorded my request, and this is what's happening. So in this mode here, you can go through different policies that I showed you a few minutes ago, and you can actually track what was going on. So first of all, we can see this key value map operation. Basically, you can read very useful information from here. If the policy fails for any reason, you will see a different information in here, and so on, so on. So you can use it also for some kind of debugging. Then we have this logly request message logging. So again, with some useful information in here, you can see some statuses and so on, so on. So actually, when we are here, maybe let me show you. So this is this logly service. And if I search the request from the last 10 minutes, I'm expecting to see a few messages. Yeah, so you saw that I did 2 requests, one to production and one to test environment. And actually, this is what we see, right? So the Apigee proxy actually called this third-party service and saved the information that they wanted it to do. So for example, I'm seeing message ID, which could be very useful, and I will show you in a second for what reason. I'm also logging request body, which is obviously not always the best idea, but for the sake of this exercise, I decided to do it. And we get the response with the same message ID, so you can easily match the request and the response to, and basically do, for example, do some kind of debugging. I also log the response status, which in my case was 201, which means the API using the post API for the social media worked, and my post was created. So quickly going to another policies. So here we have the quota. So I will change that in a second and show you how it works, because here it didn't do anything. It just verified that I didn't exceed the quota and my request was successful. The of policy, again, it's very simple. It tells me, it gives me information about the verification status, which also could be very useful. I used some, I think it was removal of the authorization header. So you can find that information in here as well. Then we have the response cache. In my case, it wasn't employed, right? Because this was the first request, so the cache was not populated, but I will show you in a second how it might, how we might use this cache. Then we see this transformation, so JSON to XML, and this is what actually you can see something interesting here very easily, because this is my incoming message, so it's in XML, and the result is in JSON, which is the format that is accepted by the backend. Then I do some validation on this JSON. In my case, everything was correct, so no issue in here. Then I do some modification. So for example, you saw that I changed this accept encoding request header, and it is a little bit different from what we saw in the Postman. Okay, so this is actually our backend. This means that the request reaches the actual API backend, and here we see what happens afterwards. So again, I forgot to mention about it. On the proxy itself, I told that it should be adding the course headers, which you didn't see in the policies because it was added globally on the proxy itself. Then we see the response cache population. Then we see the transformation from JSON back to XML. Then we see this, again, another modification of the headers. So you can see in here that something changes according to the policy that I put. And we can see the final one, which is the information, which is logging the response back to the third-party service. So this is the complete flow of this one single message, right? So let me show you a little bit of variations of that. So let me start with the cache maybe. So if I run multiple requests in a row, then you will see different response times in here. So for example, you see here that it was one of my requests that basically hit the backend, but the following one will be missing this part, which means that the hit on a cache was successful and the response was sent back directly from the cache. As you can see, it gave us a very significant increase or decrease in the overall request time. And the same with the last one, which hit this 5 seconds window. If I make a next one, it will be already the one that didn't hit the cache. Yeah, so it's again pretty much longer, and it hit the backend. Now let me show you OAuth to policy. So if I break the token, for example, you will see a different message. So this is sent directly from the proxy. So it tells me about the invalid access token. And if I go back, you will see that the message got the for1 status, and the proxy validation failed on this step. A quick look into the other policies. So maybe let me modify them quickly. So for example, let me change the quota. So I will change it so I can make 1 request per minute. If I save it, which you will see basically is really straightforward. So as you can see, I'm modifying the proxy policies at the moment, and this is very fast. So the changes are applied almost instantly, and they are ready to use. So there is no like long deployment or anything. So if I go back to trace session, I have to start it again because my API definition or proxy definition changed. And if I make the request, the first one should be successful. Oh, sorry, I have to fix the token, and then it should be successful. Oh, okay, so I already got 2 requests, right? So you should see that here. Oh, sorry, again, I need to switch back to test. Yeah, so the quota validation fails. I got the 4 to 9 status because this particular quota failed. So I exceeded the quota that I just mentioned, and then the policy doesn't even go to the backend, so it's fully protected by the proxy itself. So one more thing I wanted to show you about the API proxy. So here, all the requests were coming directly or indirectly, but through the proxy to a particular backend. But you can change that as well. So here in the target endpoints, I can define a different target endpoint. So you will see that I have a little bit of a logic here on deciding where to route my request. So in case the request header contains which is called route to, contains the value Node.js app, then I will forward that request to a target endpoint called target endpoint 1. If this header is missing, then I will forward it to the default. So the default is just some backend, right? Some backend application running somewhere. In this other case, this is another cool example because this one is another API proxy. So it's another Apigee proxy. And let me show you that in a second, that based on the header, you could expect a different response. So if I set this route to header to Node.js app, then I get a different message, which is hello world. And let me really quickly show you what that other proxy is. This is another cool feature in Apigee proxy because you can think of it as a serverless solution because it is Node.js hello API proxy, which I indirectly called by this policy. I deployed a Node.js application. So this is very simple Node.js application, right? It simply starts a HTTP server and responds with some mock data, so hello world. But you can see that there is no backend, so I'm not going anywhere. It's just hitting this Node.js application deployed directly in the API proxy. And yeah, I think this is more or less the end of this overview. So thank you very much for watching. And if you have any questions, you can contact me or Konrad through those emails. So if you have any questions or you are more interested in Apigee, then please feel free to contact us. Thank you.
Thank you very much. So that was the GFT, the guys and lads that came from our ultimate sponsor. So Big applause. Thank you very much, guys, for that. And for the next topic, let's say that I will introduce you to Andrei. That will talk about our next speaker. And for that time being, thank you very much. Logging out.
Thank you, Kuba. Thank you guys for the great presentation. And we would like to introduce Konrad Gawda, and he will tell us more about cloud performance benchmarking, and you will learn more about the PerfKit benchmarker tool. Konrad?
Hello, hi. I hope you can hear me loud and clear. So, this will be about measuring how much can you squeeze out of computing services. So my name is Konrad Gawda. I work as a cloud evangelist for Orange Polska. I have also experience with deploying telco cloud, and I do Python, and I do some trainings about that. In the free time, I'm involved in hobby electronics. I do some mountain hikes, and I received the sailor's license this summer, which I'm really proud of. So when we are starting, the first thing to say is that testing is something different than benchmarking, because testing should answer the question yes or no, is it okay or not okay, or something like that. While benchmarking says how much, how many, how fast. It gives you numbers, not a binary answer. And this presentation will be about benchmarking, but we're all humans, and even I make mistakes, and those two words are so similar, at least in my mind, so that I guess you will hear some words testing in this presentation, so please ignore them. What is the scope of this talk? So I will talk about tools, not about the results. So I will not compare performance of different clouds. I will just talk about tools to measure them. And I will focus only on virtual machines. I will not touch upon containers today. Okay, so you would like to know how fast is your cloud that you're using. How much can you squeeze out of it? In means of computing, in means of storage and the speed of that storage, or in means of networking. There are a lot of tools to measure that, and you see some examples here. So there are many clouds, there are many tools. Perhaps you would like to repeat the measurements. So you need a tool to run those tools, because you won't do that manually each time. And in fact, if you're asking for such tool, it would be nice if we could provision the infrastructure, so create virtual machines, and then remove them, clean them, and do something with the results handed over somewhere. So without further ado, there is such a tool. There are some tools. One of them, very interesting, is PerfKit Benchmarker, originated by Google. And you see the link to the GitHub, and you see a screenshot of that GitHub with a list of some tools. That's not shown in its whole length. The list of tools that it can launch. In fact, that one is in the license section, but it's a really nice place to see all the specific tools that it can run. So, in brief introduction, how do you use that? This is not a complete working list. This is just abbreviation to let you know what is the climate when you're using it. So you fetch the code from GitHub. You install the requirements with Python pip. And if you're going to use different clouds than Google Cloud, then you also install requirements for those specific clouds. Then you log into the cloud with its specific CLI tool. So for Google, that would be gcloud. For AWS, you need to provide credentials, for example. And then you run it with the command or file pkb, so perfkit benchmarker. And you may give it different options, like say what type of cloud to use or what benchmark to launch. So in the meantime, let me just launch. Let me just launch one benchmark, and so I'm launching pkb. Give it one benchmark. I'm not specifying cloud because that will be Google Cloud by default, but I'm specifying a zone so that it will launch in Europe. And let's come back to that in a minute. And in the meantime, let's talk about how it works. What are the stages? So when you do such benchmarking, the tool provisions infrastructure, and perfkit does it with a system of providers, so Python modules that run CLI tools or just SDK and call API directly. Then perfkit prepares tools. So in fact, it uses SSH commands to install specific tools. I mean, it does apt-get, or it just downloads a tar file and make install with direct SSH commands. Then it runs the benchmarks. So it also uses SSH commands to run those tools. Cleaning infrastructure. So it uses the same providers mechanism. And then finally, publish results. So by default, it creates JSON files locally on your machine where you're running perfkit, but it can also upload it to Elasticsearch, Influx, or BigQuery. That it has built-in uploaders for that. Let's check how it's going. So you see it says running gcloud. So it's using the command line tool to create virtual machine and add some resources to that. And then it is running SSH commands, so with many options. And in fact, the options end here. And this is the command that is launched directly in the virtual machine. So for example, here you see it uses apt-get to install some helper tool. Okay, a word about running that and selecting which benchmarks you would like to run. So you've seen that I can just say minus benchmarks equals and one single name, but you can stack more of them using comma. So you could do iperf and ping benchmarks just like that. But there are also sets, name sets of tests. So here you have example of running a standard set, which is a default. So in fact, Google Cloud is default, standard set is default. So if you run pkb without any options, it will run this test, this set of tests. And what tools, what benchmarks are available? So this is a list that you can get from the command line when asking appropriately about all the benchmarks that are available here. And you see 82 of them. And some of them are highlighted in bright color. That's highlighted by me. Those are the ones that are included in the standard set. So, so yeah, you see there is quite a lot of them, 82, and some of them are included in the standard set. The standard set takes several hours to complete. And you also see that there are some specific tests or benchmarks for Windows. Most of them are designed for Linux, but not all of them. We've seen the benchmarks. What about those name sets? Should I display a list of them here? Well, I will not display the list because it's not that simple. I mean, here you have a standard set, and that's what you've seen highlighted. But some of those name sets are just copies of the standard set, while there are other name sets that have their own choice of tools, or getting standard set plus one specific benchmark. Okay, so there are several different named sets of tests of benchmarks. Before going further, let's see how our little friend goes. Okay, so it was doing some preparations with SSH commands, and then finally it ran the benchmarking command, and you can see it here. Of course, it's not a benchmark that you would find useful for real production tests, because it only sends 10 ping requests. I've used that one just to make it quick so that we can see the results fast. So you see it's just calling SSH with raw command, and then it cleans the infrastructure. So it kills the processes and uses gcloud command line tool to destroy the things that are not needed. And then in the end, you see the summary of the results, but the results are also stored in a local JSON file here in the temp directory. Okay, fine. So let's go further, and let me make a small detour here, because in the beginning I mentioned that I was involved in the deployment of telco cloud. So this is called NFVI, Network Function Virtualization Infrastructure. And this is a set of small distributed data centers to process the telecommunications traffic and run some functions that are not exposed to customers that are part of the telecommunications network. And let me show two challenges I found here. So one of them is that when you're a provider and you're benchmarking your networking performance, you're not just interested, I run 2 virtual machines, what's the bandwidth? Because if there is a specific server, the traffic could go between virtual machines that are running on the same CPU. It could run on different VMs running on different CPUs on the same server, but it could also go to another server in the same rack, or it could go to a VM that is running on a server on a different rack, and that's a difference, because it is traversing different set of networking devices. So, and currently this is, for me, this is open question. Like testing benchmarking that we do today with those tools, like PerfKit. So you're using the client's view, so you don't have much field to play here. You could use anti-affinity groups to make sure that 2 virtual machines are not on the same server, but rest of those options as an open question. Okay, and the second challenge here, and the section is named NFVI Adventures, and well, this one is for me, it brings to my mind the stories about Castaway, because in your normal cloud user life, the situation is like that. And so I'm here, I'm connected to internet, I have the cloud API available, and my virtual machines are running on the cloud. They also have internet access, and we can connect to each other via SSH. But then, sometimes, for example, if you're benchmarking a staging environment, a staging cloud, you won't have access to the API, so only web user interface may be accessible for you, because that's a fresh environment that is not yet security tested or something like that, maybe many reasons. So for that, the resolution is to use static VMs, so that the benchmarking tool will not create virtual machines. It will just ask you to give the credentials and IP address to connect to them. Then it is quite common for the telecommunications infrastructure to be disconnected from internet. May seem crazy, but that's, as I told you, that's not about customer-facing components. It's about the different pieces of the network that connect to each other via technical networks and no internet there. So for testing such a thing, you would need an image with of VM with pre-installed tools, so that it will not install them during each run of a benchmark. And then finally, the deepest castaway mode, you don't have SSH access to your virtual machine. You only have access to web user interface, and you do have a web console to interact with the VM, but nothing more. So here, all the uploaders for the Elasticsearch or whatever will not come in handy. At least you install this Elasticsearch on another VM on that cloud. But one of the approaches to deal with that is keeping results in files and then getting those files using some disk image that you can connect to virtual machine, disconnect, and then download. Okay, and with that, I would like to refer to PerfKit again, because this is what you've seen about PerfKit, but happily, it has a mode with static VMs. So here, you provision the infrastructure by yourself, you clean it by yourself, you only give credentials and IP addresses to PerfKit. And so those two fields are empty. And there is also an option to say install packages false, so that the VM that you're running has already all the benchmarking tools installed. One interesting thing that I missed to tell you before, perhaps, is in that table, I used that bracket to mention that by default, the VM is created and destroyed per each benchmark. So if you have a dozen of benchmarks in your set, for example, that you're executing, then 12 times the tool will create the virtual machine, do the test, do the benchmark, destroy that, and create new one. Okay. So while we are still around telecommunications area, there is that OPNFV project with its yardstick tool. And here the approach is, it is quite similar, but the approach is more based on the strict definition of test cases. And test cases here are something really similar to benchmarks in yardstick, but they're defined separately. So for example, you have OPNFV _ yardstick _ TC021 or something like that. And each of them is defined what should it measure and under what conditions. And in the implementation, you see that they use some tools, so that's no mystery here. But some of them are using several benchmarking tools at once because they're testing some scenario, and that's and that's maybe a bit of difference because it's not the test cases are a bit separated from the tool that you're using. And well, the test cases are defined, and the implementation of those test cases in the yardstick tool, in the code itself, may differ in maturity, for example. And there are some tests that are used frequently, some that are working well but are not used that frequently, and there are some that are not maintained or made sure that much. And that's not a complete list. That's only a top of the table. Okay, so yardstick comes with this idea of test cases. How do you use that? So similarly as for perfkit, similar abbreviated list, not complete. The main way is to launch a Docker container from the OPNFV repository that has everything that has the benchmark manager installed. Then you need to set up credentials to your cloud, and here it's the credentials for the OpenStack cloud, because Yardstick is only focused on OpenStack clouds. Then you run OpenStack env prepare, and this command builds VM image. It may also upload it, but you could also upload it to OpenStack by yourself. So just give it a name and be aware it's stored in the TMP directory when it's produced by the env prepare. And then you run a test case with Yardstick task start and a path to a YAML file that describes the test case. So let's compare it with the table. Perfkit you see on the right, and here on the left or middle-ish is the Yardstick. So provision infrastructure, it uses OpenStack CLI, pre-build the image. You've seen the command for that, and in fact you did do that before, so this is why the arrow here. So when you provision infrastructure, the tool launches VMs using that image with pre-installed tools. Then it uses SSH to launch, in fact, not the raw tools, but scripts that are also included in that image. During the build image phase, and then afterwards it uses again OpenStack CLI to clean the environment, and it could push the results, so it can push to Influx or using some predefined REST interface, and it also does store the JSON files with the results locally, although you may find some small differences, like not every single piece of data is present in both worlds. So, and that may be a bit tricky if you're using that, but the differences are not that big. Okay, and if we're talking about hints for using Yardstick, so let me take you for a tour inside for just checking bits of its code. And to be clear, I'm not making fun of that it's implemented in that or another way, because, well, we're all involved in some programming projects and we see how this evolves. So I'm rather showing you what are the not obvious things here. So let's see what happens if you say Yardstick env prepare. So you would like to build your image. So the Yardstick tool starts some task, and in fact it uses REST API to connect to the server of that manager, running in the same Docker if you're using Docker pre-installed image. And here inside, it launches function that launches function load images. So beware, it's building images, but it's called load images, and it launches some script. The script is defined in constants file, so it's a shell script, and here beware, it's located in this test CI directory. So, well, that was a surprise for me when I was looking for the script. Okay, then the script calls some other actions, and beware here because it has a condition. In some scenarios, it launches shell script that builds the image, but that's not that common scenario. In a typical scenario, it launches Ansible to build yardstick image, and we'll continue with that scenario. And the yardstick and the build yardstick image playbook downloads the base image, ch roots into that, and launches another playbook that does the job. So it installs the dependencies, downloads the tools, and so on. Oh, that's the journey your code executes when you run env prepare. Okay, and now because I mentioned in the beginning that I work for Orange, and I'm working with a cloud that is called Integrated Computing Standard. And I'll just tell you 3 facts about that. So it's run by Orange's daughter company, Integrated Solutions, which is an IT integrator company, so they can give great support to customers. It's located in Poland, in main Orange data center. This cloud is located there, and it is based on VMware vCloud Director 10. So that's nice because enterprise customers may be accustomed to that, and we can also propose simple integrations, or for example, disaster recovery for them. But this platform has no provider in PerfKit because, as I mentioned, different clouds have provider modules in the code of PerfKit benchmarker, and you can see a screenshot of GitHub here. For example, there is one for OpenStack and for other clouds, but not much for VMware vCloud Director. So if I would like to run some tests there, we could use the static VMs of PerfKit. So I mentioned in the beginning that you just use the command pkb.py, and you can tell what benchmarks to use. But you could also tell it which static VMs to use. And there is a way to convey there a JSON file with just a list of virtual machines that you have already provisioned. And you see highlighted the install packages option that I mentioned before. And so that JSON file is quite simple because you just define a list of VMs, and PerfKit benchmarker, while running consecutive tests, just fetches next, next, and next from this list. So here, in fact, you have iPerf and CoreMark. iPerf launches 2 virtual machines because it needs to check bandwidth between something and something. So it would take a first one and then a second one from that list. And then CoreMark would take a third one to measure a CPU. But if you would like to run dozen of tests, you would need to have dozen of virtual machines running. Or you could just, or if you'd like to have 100 of tests, you'd need to pre-provision 100 of virtual machines waiting there, each for single test. Or, in fact, you could just copy-paste the same definition 100 times, and then this single virtual machine would be used for all the tests. And that's fine, that's nice. But wait a minute, what about iPerf? Because it needs 2 virtual machines. So it will grab first the virtual machine and then the second from the list, which is the same as the first one. No. So we cannot go with that. But there is a second option of telling Perfkit benchmarker which static virtual machines to use. And this is benchmark config file. And you use that to set up different options of the benchmarks if you're not happy with the defaults. So you use it not only with static VMs, but you could. And for example, you could write a file like that. So it defines virtual machines to be used. And here you could define 2 different virtual machines that are waiting for the benchmark. And then in the iPerf configuration, you can just tell it to use 2 different VMs. And in fact, those two communication ways work well together. So if it encounters iPerf, it takes VMs from that. If not, then it just takes next VM from that JSON file. So if you're going to use static VMs, that's a nice way to go. But still, you would need to pre-provision the virtual machines each time you'd like to run the test. So, of course, that's a short-term approach. And the long-term way, the good way, is to implement your own cloud provider here in the Perfkit. So, with the vCloud Director, typically users interacted with Web Console, or rather web interface that looks like that, and of course that uses the vCloud Director API under the hood. But there are different ways to interact with this API, and one of the best possible things there is Terraform. And it has a great support for vCloud Director. So that's wonderful, but in fact, its philosophy differs a bit from the from the Perfkit benchmarker approach. So it stores state in a different way. Perhaps there is some smart way of integrating that into Perfkit, but as I was looking into it, not that obvious. So typically, Perfkit benchmarker uses CLI tools, and there is such tool. It is called BCD CLI, and well, it's there. It works. And there is also Python binding for the same API, and in fact, it's used by that command line tool. That's a nice thing, because while exploring the code of one, you see examples of usage for another. The documentation of Perfkit benchmarker encourages the developer to use command line tools because they are easier for debugging, but bindings are also okay. So I worked with some proof of concept. And let me just launch that. Okay, let me just launch that so that we have some printouts in the minute. So PKB with a benchmark, and then I tell it which cloud to use, and that would be the vCloud Director that I've implemented there. And let it connect and start running, and we'll come back to that shortly. And in the meantime, let me show you how to implement such a provider. So this is an abstract one, just to make it very brief so that it fits into the screen. So you define a class that needs to have several methods, And one of them, most important, is _create. You have a helper that can issue commands. So you just run your command line tool and some options. So you need to convey a name and the image file to be used to launch this VM. And you also need to inject an SSH public key for that and username given by perfkit. Okay, in fact, you can select the username by yourself, but the public key is something that is generated by perfkit. And then in post create, by the way, notice the nice retry decorator that is also given by perfkit. You need to check its IP address and internal and external if you have to, and SSH port, and fill that in. You also need to define several other methods, but this is a key one. Okay, so as you see, this tool is running the VCD command line, and for example, that one is checking for list interface cards, and it's checking if the IP address is there on the virtual machine. So in a minute, it should fill that, and well, you've seen that. You run it just with cloud and the name that you've given. You need to enter that into several more files, but that's just to say, hello, I have this cloud and you use it, and it's named this way. Please take it into account. And well, the last module of my talk is about implementing your own benchmark. And that's even simpler. I mean, you only need to define a file. You only need to create a Python file and no modifications at all in all the other code of the perfkit. So you see here, it's a working example. In fact, that's the one that I'm launching right now. But for sake of clarity, let me remove some boring stuff. And this is almost functional, but it shows the core things that you need to do. So you need to give it a name that will be later on used. You need to give it a default config, and it must use the same name as the name of the benchmark. It has a description, and it uses default single core. That's most of the benchmarks do that way. Then it has a run function. It's no class directly defined in the file, in the Python file. You fetch the VM declaration from the arguments, and you can do vm.remote command. And here it's just like that. I just enter here the command that I would like to run, and then in the std out, you've got the text that you need to parse. That's the most difficult part here, and then you return an array of samples. So and it's name, value, unit, and some metadata that you put here. So let's see if it finished. Yeah, it's succeeded. So you could see, yeah, the results are here. Let's just look how that file looks like. So it has the latencies measured by ping, and by the way, some other things that perfkit checks by default, like what CPUs are there. Okay, we're getting close to the end of our part. I know there is something more important about this benchmark that I wanted to tell you. But let's come back to that in just a second. And in the meantime, let me just summarize that I hope now you can that now you're quite aware how to use perfkit benchmarker, and you're also aware that there are other tools like Yardstick. Things that I find that would be useful to do next, and I put them on my to-do list, or rather perhaps to do, is implementing the proper vCloud provider, because that one was just proof of concept, and perhaps implementing the OP NFV test cases as benchmarks. And feel free to contact me if you would like to exchange about that. And I also put some things that might be interesting here, like the Integrated Computing Standard webpage, the list of benchmarks for Yardstick. Here is a Cloud Performance Lab and Yardstick. Here is my copy of Yardstick with some corrections, because the default one has some problems and wouldn't build the image as for today. So there's some corrections, and there are also test cases with a counter project that I didn't have the time to touch upon. Okay, and I remember what was the thing that I wanted to mention, and I conclude with and I close with that. So as you've seen, I use the VCD command line tool. So don't use it for creating provider, because it shares some things with an authorization. It also shares the virtual data center on which you're working in. So if you need to switch between several ones, and you need to create several virtual machines, and Perfkit does that simultaneously for Hyper, for example, it may clash. So when I will be implementing that for good, I will be using just the Python binding. Okay, I hope that was interesting for you, and have a lovely rest of the conference.
Thank you, Konrad, a lot. It was a great topic. And let's move to the lunch break. And after the lunch break, when we will come back, we will have the presentation about from Maciej Nowicki from the company GCP Poland, and he will tell us about the using Google Cloud Platform services dedicated to manage lifecycle of your machine learning models. So might be interesting for all of us. Thank you, Konrad, as well, and let's go. Thank you a lot. Cheers.
right, Maciej? Maciej, are you there? Oh, there you go.
Yes, I'm sorry. Sorry, my bad. I was on mute in StreamYard, and I tried to use my button on the headset. Okay, I'm ready.
Hello, Maciej.
Hi, Piotr.
So I would like to introduce our speaker from GFT, talking about very interesting topic, serverless MLOps. This is the first time I'm hearing about this, so I'm really eager to hear about it. And I won't take any more of your time, so start freely to speak.
Okay, sorry, some technical issues. So I assume you can see my screen. Okay. Today I'm going to walk you through the topic of MLOps. So kind of DevOps for machine learning and artificial intelligence. First of all, I'm going to explain for those who are not familiar with this idea why it's required while working on AI project. Then, as a continuation to what MLOps exactly means, I will present some components of MLOps environment, let's say, and eventually I will talk you through several services available on GCP that may be able to compose MLOps in serverless mode on GCP. So goal for today is to answer the question from the title of this presentation. Okay, so first of all, if any of you ever worked on data science, machine learning, artificial intelligence related project, there is very high chance you use Jupyter Notebook or similar notebook kind of tool. If you are not familiar, just in case, let me consume 1 minute of your time presenting what it is. Just need to move. Where is it? Sorry, just wanted to present all this. I hope you can see the notebook. So what the notebook is? This is some kind of interactive document which can be used to both run the code and also explain what your code is doing in very informative way. So one of it's like document, and application itself is like client server application, where client is web app, HTML based user interface, and under the on the server side we've got, in the case of Jupyter Notebook, we've got for 99% of cases Python interpreter running in the background, processing your request. So as you can see, this is not mine, but this is a very good example of what you can do with Jupyter Notebook. So let me scroll down a bit, and so we've got some text in text, links, description of your idea. Then we can see some command line execution steps so you can describe how to prepare your environment to run your code as a part of the document. Next thing is just your code that do exactly what you want to do. And also you can include any kind of formulas, or if I scroll down a little bit, or it can be graphs of, in this case, this is graph of a deep neural network, or even you can embed into this document images as well as any kind of plot. And once this is once you finish your experiment, you can save this both as Jupyter Notebook and share with your colleague. And once he opens the document, all the results of code you executed, plots you produced, etc., it's in there. So he can just, with no need to run your code, see results of what you've been working on. And as well, you can produce PDF from that and print out and present it to your manager. Okay, so enough of Jupyter Notebook crash course. So this tool has some limitations. It allows you to run Python, any kind of, but I prefer, I prefer Python, so I'll be referring to Python. Any kind of Python code, but it cannot access your code from the external world without any hacks. So this is not like server for your Python services, endpoints, whatever, or machine learning models. It does not work this way. It's just document creation tool. So for any production use case, it's not what you're looking for. If you build a model, exported it, you need to use a different tool to share your model. I mean, to allow other people to use your model. Another thing is such that Jupyter Notebook has very poor integration with Git, let's say, because Jupyter Notebook documents, I mean files you produce, are some JSON files that contains a lot of information that are not well tracked by Git itself. So using Git for tracking changes in your notebook is not the best idea. As well, this also does not solve problem of moving your experiment to production. So just you produce notebook and that's it. There is a lot of other steps you need to do to share product of your work. Okay, so maybe you would ask that why DevOps is not enough in this case. We all love DevOps. It simplifies our life a lot, automates everything for us. So why it's not enough for machine learning kind of projects, and why another XOps has been developed? So main reason for that is fact that machine learning based software has some major difference compared to regular software we produced for a lot since we started working as software developers. So in the case of regular code, of regular software, what we do, we've got some input data from business we are working for, and we implement program based on business logic that product owner provided to us. Then we just use our program to process input data, and we produce output data for business. In machine learning software, it's completely opposite, because what's input for execution is the same set of input data we used for regular cases, but we also need expected output data for corresponding data points. And what we do in this execution stage, we just try to build something that can map input data into expected output data. And this is our program. So instead of building program on ourselves and producing the data, we need to first build program from set of data, which then can be used to process previously unknown data. Escape. And so this is main difference why regular DevOps approach does not fit in there. Less important reason for developing MLOps is a completely different set of tools we use while working on ML related projects. Some I just put most popular tools on the screen, but obviously some of them would fit into Git and Git based DevOps process, let's say, but it requires some hacks. So that's why dedicated tools for solving this type of problem has been developed. And just for sake of clarity, you may heard the term AIOps, and just wanted to point out that it's not exactly the same, because what we call AIOps is any attempt to use AI or machine learning to execute your operational tasks. So one thing we did that fits into AI ops definition is chatbot we built for one of our clients, where a chatbot was executing Git commands under the hood, let's say, according to conversation with user. So when someone wanted to create new project in Git, or create branch, or do any other DevOps related activity, user could use our chatbot. I mean, speak to him, and right set of commands has been executed under the hood. Okay. Next part is components of the process. So when we are working on machine learning AI project, we always start with some problem to solve by for business people in our company. Sometimes it can be driven by problem that cannot be easily solved using regular software development. I mean, the one where we define business requirements and implement it according to what business says. Maybe they just have no idea, or maybe problem is too complex, too broad to be implemented this way. And we've got a lot of data, so this is perfect candidate to check if machine learning can work for us in this case. Another thing, maybe just business get to us and told us you need to solve this problem using machine learning, even if that it does not make sense, because we want to use it as our unique selling point, that we are using the fact that we are using artificial intelligence to solve specific problem, or we just want to do it for marketing purpose. It happens. I've been there. It sometimes happens. It's a hot topic nowadays. So everybody wants to solve problems using machine learning or artificial intelligence. So I'm not surprised such a request sometimes appear. So first, once we are hired for this kind of project, first thing, the point on left-hand side of this image is a design stage, where we need to extract as much requirements and as much information from our business. There is also mentioned as ML use case prioritization, because maybe we are the only one who knows how to do machine learning, and five departments ask us to do something for them. So we need to discuss with all of them their priorities and create queue of tasks for us. Also, last but not least, in this design stage is check for data availability, because it's quite often that everybody wants to use machine learning, but when we come and say, hey, we need all your data production, some very sensitive data can be masked, but we need terabytes of data to make it useful, and then they are less interested, because it's security, compliance, etc. It starts becoming a problem. So sometimes we can end up project at this stage. But if we manage to move to next stage, which is the most interesting part of data scientist, machine learning engineer, whatever person, is model development. So we need to take data, process data, do all the cleaning, feature engineering stuff, etc. And eventually, when we've got perfect data set with no gaps in it, etc., we can start working on model engineering. So we test various industry standard models, or sometimes try to develop something bespoke, and experiment with that, testing various cases, various parameters. We need to do hyperparameter tuning task, which takes some time, and it would be good if we can track it. And eventually, when we are satisfied with our model, we need to test it and validate in order to prove that it gives value to our business. It really solves the problem we've been asked to solve. And after this stage, we've got some model, and we need to share it with the rest of the company. So we need to deploy the model, which is not always as simple as just create REST endpoint. It's required to incorporate it into existing CI/CD pipelines, or create own pipeline, but which is in line, the one which is in line with your company standards. And eventually, it would be good if we can monitor how our model is performing, both in terms of performance. I mean, if we are producing results quickly enough, and if our results are good enough. And all of this should create this iterative infinite loop. So once we deployed model, we cannot just move to another project and give up, because performance is going down. We collect more data, which we can use to retrain model. Sometimes we are just making wrong predictions, and we need to completely rebuild our model, because we've been overfitting to examples provided by business on design stage. So this creates very iterative process, and we really need a good set of tools to do it right and avoid any manual actions, because with one model, one simple model, okay, and one data science team, it should be possible, but it's boring, and let's just automate everything. If the people developing REST API for your customers can do everything fully automated way using CI/CD pipelines, DevOps approach, etc. Why we shouldn't why we cannot do the same? So one comment for today, as this is Devfest, not Business Fest. I'm not going to discuss design stage anymore today. This can be this is for different audience. So let's move on with proper meat. And okay, eventually we are on MLOps on GCP slide. So generally, I'm not a person that needs to be up to date with all the latest and coolest stuff, but like month ago, I was preparing offer for US-based asset management company that wants to move to GCP with their data pipeline and data science and machine learning models, which help them in decision-making process. And when reviewing what's currently available on GCP, I spotted several services that are in beta currently, but they caught my attention because I quickly connected dots and saw that it's no longer required to use fully featured tools like Kubeflow or TensorFlow Extended, mentioned on the slide as well, in order to do MLOps in serverless mode. So first thing I want to present to you today is AI Platform Data Labeling Service, which helps you in data labeling process in such a way that you don't have to do that in Excel, let's say at this point. I will go more into details in a second. Next part is for AI platform jobs and models, which you can use to train your, let's say, standard framework-based models and deploy them on GCP. We've no need to create Kubernetes cluster or running any VMs or etc. And at the end, I will quickly walk you through AI pipelines, which are Google version of Kubeflow pipelines and TensorFlow Extended as well. So let's start with data labeling service. So it's integrated into Google Cloud Console. So we get a really user-friendly user interface, graphical user interface, and whole data labeling service is a service you can use to provide ground truth values for your model evaluation or retraining process. Or just preparing data if you want, if you need to, let's say, broadcast this task to wider audience, and you do not have tool for that. So here it is. Just upload your data, define data set and two other items which are data labels and instructions for people who will be labeling data for you, and create data labeling request. So the whole idea behind that is such that you can, if you've got a lot of data which needs to be labeled, so you can train your model, and you are not able to do that on your own, you want to hire people for that, and those people does not need to be doesn't need to be SME in the area of your project. So you can provide very extended instruction for those people, and they can try to label data for you. And we've got two modes of operations. One is you can ask your team, so people that have accounts on GCP in your organization, to label data for you. So in this way, in this case, data labeling service is just tool to execute this task. And the second mode is you can hire people from Google. So this kind of CAPTCHA thing, let's say, and people outside of your organization in very secured way can access your data for a very short period of time, just to label your data, and then they cannot see your data again. Okay, one problem with this tool is such it does not support boring tabular data. So you can only work with images, videos, and documents. There is no way to use it to label, to, for example, estimate, to provide value of house if you are trying to compete in Kaggle competition for house pricing, or build your own tool for house pricing. It wouldn't work. So we can not at this stage, but please remember this is still in beta, so maybe it will change in the future. Very cool thing about this tool is the fact that the way you define your data set is completely separated from labeling tasks. So it's not like using Excel, which you just need to share with people, and you use the same document to provide more examples, and on the other hand side, they used to provide labels. And once you define the whole process, so define data set, labels, and provide instruction, which is just PDF document, you can you can create data labeling requests, so it's communicated to your data labelers. In addition to nice user interface we've got, it's also possible to define everything from Python and Java directly, or just using REST API. Let me just switch for a second to Jupyter Notebook, because I created data set of Simpson characters, and I just did it completely from Python code. So I'm not going to go through this document. I will share it with you after the presentation, but just wanted to tell you at this stage that because this service is in beta, it's not fully functioning, as at the moment no one can submit a data labeling request. Google says we live in COVID times, so they are short of staff to execute this task for you, so you are not able to create data labeling request, and any call to this API endpoint fails. It also is visible in, let me show that. Okay, it's in gray. It's this button is disabled, and comment is exactly the same. So not this time. You need to wait to either end of pandemic or just end of beta, I guess. Okay, going back to presentation. Oh, not this one. Okay. So as I said previously, it supports images, videos, and natural language documents. For images, we can do image classification and object detection in different ways, as you can see on the screen. It's like box, oriented box, polygon, etc. For videos, we've got classification, image recognition, object recognition, like in the case of images, and natural extension for image recognition in the case of video. So object tracking is also possible there. And for documents, we've got pretty standard set of things, so classification, sentiment, and named entity recognition. And as I said previously, it can be done by your team or specialists provided by Google. Okay. Next item is combo of jobs and models. Jobs simplifies the way you train your model, so you don't have to do it on your own or run a Kubernetes engine or any kind of virtual machine. You just provide data set, select framework and model you want to use for training, and execute training task based on labeled data you provided. At the moment, for Google, standard libraries means scikit, XGBoost, and their own product, which is TensorFlow. The problem with this tool is such that at this stage there is nothing for result comparison or for interpretation of results of training of your model. There is any graphical user interface to see how well performed your model, and obviously without that you are not able to compare results of different training runs and decide is it getting better or worse. The only place you can find metrics for your training are in logs. So you need to build some kind of log crawler to extract the information. So this is the downside of this tool. But when you deploy your model on AI platform models, in addition to REST endpoint, which is fully serverless, scalable, and you don't care how many users are sending requests to your trained model, the coolest thing about AI platform models is the fact that you can enable periodic evaluation of your model. So each time someone sends request to your model, result of prediction is stored into database, and this tool is integrated with data labeling service. So you can just periodically ask your staff or Google employees for having a look into data and label data that has not been used for training so far, and it comes from end users. And you want to do, if you can do two things with them. One is this evaluation, so you can just check if your model is performing good enough on real production data, not only on data you had upfront before project started. And as well, you can use those data for model retraining in next iteration. You can access both jobs and models from CLI, so gcloud command line tool and REST API. So it's quite simple to build CI/CD, let's say, for MLOps using cloud build. So still we are in this serverless boundary. Nothing run on server you need to maintain. A bit of glue and duct tape, and it should be working. So you can fully automate this model evaluation, retraining, etc. In addition to standard libraries I mentioned at the beginning of this section, it's also possible to use non-standard models, so anything you want, both for jobs and models, so you can train custom model and deploy it, but it's not the simplest task. So if you really need to use dedicated model and you really want to use AI platform jobs and models for that, you have to be very careful building your solution. So for training, you need to provide Docker image with all your code, which needs to be compatible with AI platform training procedure, let's say. And but on the other hand side, once you build such a image, you can share it with people. And I've tested the one for PyTorch, and it works. So even if PyTorch is not supported by default, it's still quite easy to use it, as long as someone was kind enough to share his work with you for free. And for the hosting side, so AI platform models, your Python code needs to to follow specific interface defined by Google, and you can only deploy your custom model using CLI, because for this you need to select not to select which framework you want to use, and graphical user interface in the Google Cloud Console does not allow that, so we need to use command line interface. Okay, and so that was for small tools, small services provided by Google. But if we need something more consisting of more features, more mature, let's say, we can use Kubeflow pipelines, and the serverless component of this is fact that you can deploy it from AI platform pipelines module on Google Cloud Platform, which simply means that you deploy Kubeflow from GCP Marketplace. So once you go to AI platform pipelines and press this new instance button, you are moved to Marketplace, where you can create new Kubernetes cluster or use existing one, and deploy any other services like database or Cloud SQL database or cloud storage bucket for artifacts, etc. And this can be done for you by simply selecting it from in this designer, in this creator, let's say. And once everything is done, so we need just to wait a couple of minutes for everything to be configured for you. You can see your Kubeflow pipelines deployment in this AI platform pipelines. Those settings, this button is not for settings, it's just some extra info, at least when I was testing it a couple of days ago. And if you press this Open Pipelines dashboard, you are moved to some endpoint created for you, some URL, which is in googleusercontent.com domain. And this is standard Kubeflow console. There is a couple of demos, tutorials kind of thing provided for you, so you can test if it's working without need to deploy your own model, and use it as any regular Kubeflow deployment. But the serverless piece is in this, let's say, to be honest, in Marketplace. But it's nice thing, you don't have to configure everything on your own. Just provide parameters, and here you are. For those not familiar with Kubeflow pipelines, just wanted to say that it creates directed acyclic graph of task, where each task is just let's say Docker image, a service running a specific step in your pipeline, in your MLOps pipeline for you, and you can do anything you want in here. There is obviously there are some standard tools, but standard steps, but you can do you can implement any pipeline you want. And also you can use API to that, but recently also in beta we've got Python SDK for this. So we can just write some Python code and use the Kubeflow SDK for Python to convert your Python code into containers, which will be then used in Kubeflow pipelines. And last thing is TensorFlow Extended, which is simply Kubeflow for TensorFlow. So limited to TensorFlow, but it gives you a lot of components which you may need to create manually in the case of Kubeflow. So if you want to use TensorFlow and you need something complex, TensorFlow Extended is the way to go. Okay, so just to summarize my presentation, it is possible. MLOps in serverless mode on GCP is possible. If you want to start with something small, you should build something based on data labeling service, models, jobs, and cloud build. Use some duct tape and glue something, and it should work. It should be enough for simple cases. But if you're already proof that your model is working and solves problem of sponsor of the project, and it will be extended, it might be worth moving to AI pipelines, which are just better tool, more sophisticated, has more features. So, and this is what I recommend for simple cases. So data labeling service for processing, basic data processing, then AI jobs for the training of the data, AI models for deployment, and we've got continuous evaluation loop using this AI models continuous evaluation, which sends requests to data labeling service. And at the bottom, we've got cloud build, which solves all the incompatibilities between those services. And that's it. Thank you very much for your time. I hope I gave you a grasp of what MLOps is and how to use it on Google Cloud. Hope you enjoyed.
Thank you so much, Maciej. That was a great presentation. All right, everyone. Next up, we have Konrad Cłapa and Tomek Porożyński as our next presenters. And they'll be presenting on the topic of building anything in minutes using Terraform and GCP. So yeah, everyone give them a warm welcome.
My name is Konrad Cłapa and I have Tomek Porożyński with me. Today we're going to talk about building anything with Terraform and GCP within minutes. So basically the session is around how you can build your infrastructure in GCP using infrastructure as a code. Okay, a quick agenda, what we're going to do. We'll have a short introduction of ourselves, where we work, what our interests are. Then we talk about Google Cloud in general. I guess there might be some of you that have less experience with Google Cloud or would like to start up with it. Then we talk about infrastructure as a code, just to give you an understanding of why would you want to use it, what benefits it has. Then we'll start talking about Terraform. So the main topic of our today's speak, we're going to talk about how to test Terraform, how to auto-generate Terraform, and we'll sum up with some next steps if you guys want to learn a little bit more about it. Okay, so quickly who we are. We're Anthos R&D Poland. We basically are a Google Cloud partner and other service providers. We personally work for R&D of the product space on GCP. We have like over 100 developers in Poland, in cities like Bydgoszcz, where our headquarters is, Łódź, Warsaw, Krakow, Wrocław. And overall, Anthos is quite big. It's over 140K experts worldwide. So quite a big footprint we have. On top of it, we do actually provide services to Google. So if you guys are using bare metal solutions, that's Anthos that has delivered this, and those are the servers that the Boolean servers that Anthos produces in the backend, and all automation over it to deliver this service is coming from Anthos. And also we deliver Database Hotel. So if you guys want to run Oracle on GCP, that's also us. Okay, myself, I've been with Anthos for the last 10 years. I'm kind of certification junkie, as you can see. I mainly specialize in public cloud right now, but I have VMware, very strong VMware background. I try to inspire people with what I do. I'm a book author. I'm also a local Bydgoszcz cloud GDG leader. So we organize a lot of meetings, and we actually participate in this particular event as well, helping to build the cloud path. And also GCP trainer. So I try to teach people GCP. In my free time, I love running. I try to do windsurfing whenever there is a chance to do that. And basically trying to get things done. Okay, Tomasz, can you say a couple of words about yourself?
Sure, thanks, Konrad. So at Anthos, I'm working as a cloud system architect. Before I transitioned into more DevOps role, I was working in IT operations as a storage administrator, so I think that's my stronger side. I'm also a technical blogger and YouTuber. I like to learn new stuff and I like to share the knowledge. So if you want to check some of the tutorials I created, the links are on the screen. After work, I like to travel, I like to snorkel, I like to read a good book, even something more than the Phoenix project. All right, thank you. Let's move on.
Okay, thanks, Tomasz. We also would like to learn a little bit about you guys. So if you can, put a couple of words. Obviously, we don't have time to interact, but if you can put some words in the chat, we would love to understand who you are, if you're coming from the DevOps or the cloud world. Very interesting for us. Okay, let's start with the introduction to GCP. So let's start with the definition, right? So this is the official definition from the United States National Institute of Standards and Technology. It says that the cloud should be on-demand and self-service. It should have broad network access, rapid elasticity, and measured service. For me, one of the most important things is API-driven. So you need to have API access to your cloud so you can automate things, and that will be very important for Terraform. And obviously, there are multiple public clouds. We're here to talk about GCP, but we know there are others on the market. Why would you care about Google Cloud, especially here in Poland? It seems like Poland is getting more and more traction when it comes to Google Cloud. Google is quite actually investing a lot of money in development in here. We know that in Warsaw we have a development center where there's actually Kubernetes and Anthos being developed, which is quite a big thing for me. So I think it's worth looking at. Another thing is that there is a region being built in Poland. That's my estimate. I think next year, somewhere next year, or 2022, we're going to have finally a region in this side of Europe, right? So it seems like it's going to operate for all the countries, all the Baltic countries here. So it's quite a big thing as well for me. Okay, and why would you be using GCP? For me, GCP is Kubernetes, big data, machine learning, high security, multi-cloud, and developer focused. So, guys, if you're looking for those features, probably GCP is for you, especially, that it's built on open source. So you can actually, if you don't want to use GCP and you want to use it, center, you can use equivalent of the open source products that Google is offering this service. Okay, a short introduction to Terraform. So what is actually infrastructure as a code? You would treat your infrastructure as software, right? So probably a lot of you are developers. You define your software as a code, obviously. But what about the infrastructure? So you can do it as well. And you can create like a stamp that you can use to deploy new environments. Yes, so this would be decreasing cost because you wouldn't be defining it per environment, you wouldn't be deploying manually. So it saves some time. The deployment is faster, and it also reduces risk because you have a standard template you can deploy. You can apply some services principle on top of it, and you have a streamlined way of deploying your services. Okay, and what about Terraform? So Terraform is actually an open source project developed by HashiCorp. It's using HashiCorp configuration language, but don't be scared. It's pretty easy to learn. You can actually learn it in a couple of weeks. We have people that became experts in Terraform, especially that there are so many nice tutorials. So don't be scared about it. Having a week time just to learn it, to copy the examples and do it yourself, you're gonna master it very soon. And obviously there are multiple providers. We're gonna talk about GCP, but there are providers for almost any major cloud software endpoints that you can imagine. Okay, there's still some alternatives for Terraform, like Deployment Manager, which is a native tool for infrastructure as a code. In GCP, you have Ansible from Red Hat, and Anthos config connector. So Anthos config connector is an application that you install in your Kubernetes cluster, and you can declare all your resources in GCP as Kubernetes resources, which is pretty cool. Why would we use Terraform? Terraform can be used for any cloud. So let's say you're using multiple cloud providers, the Terraform template, obviously there will be a different provider, but the tool you're using for automation is the only one tool that you have to learn. So the learning curve is smaller. It's very similar with Ansible. However, with Terraform, my personal view is that there is much more effort put in developing the Terraform providers rather than Ansible modules at the moment. Okay, so the basis of Terraform, as we said, it's open source, but there's also enterprise version. The enterprise version is giving you a workspaces where you can collaborate with other users. So if you know, Ansible Tower is quite similar. So basically what they're trying to do is to make this enterprise ready, where you have role-based access controls, you have all those environments where your user can collaborate, right? If you don't need that, the open source is good enough just to deploy the templates and lifecycle your objects in GCP. The last version is cloud. So obviously the enterprise, you install this on your hardware or virtual machines, while cloud is basically software as a service, right? So you just create your account, you can create your spaces right ahead. So if you don't want to bother about managing the Terraform enterprise infrastructure, that's the way to go. Okay, there are multiple versions of Terraform. The last version is 0.13. There are quite some nice enhancements in there. However, we're still using 0.12 just because of its stability, and it has been proved in battle, I would call it. We're gonna look at Terraform 0.13 as there's some really nice enhancements that we've been waiting for a long time, very soon. Okay, the first step with Terraform. So basically you define your infrastructure in YAML, you run Terraform init. So Terraform would actually pick up all the providers of the software, I would call it, all the binaries it needs to pick up from the Terraform repositories, download it into your machine, and make sure that you can actually execute the plan. The next step is to run Terraform plan. Terraform plan is actually going to show you what will be applied without applying it. So you can see all the changes that will be done. So you're on the safe side, and then you can decide whether you want to apply it or not. And finally, you have Terraform apply, which is actually going to apply the changes into your environment. When it comes to the files, I was saying that we're using YAML files. So those there are multiple of them. The most important is the main Terraform file, where you will define your resources. So you can actually put everything in there, but you can also divide it into multiple files. So you can define your providers. In our case, it's going to be Google provider. You can define your variables in here. So basically, that's the definition of your variables. The Terraform state is actually storing the state of your resources that you deployed, either to the endpoint you're using. So basically, once you deploy, let's say, Google storage, a couple of virtual machines, this file will be storing the information about those, and will keep the IDs. And finally, you have the output file. So that output file is actually defining all the information that will be displayed to you once the Terraform has run. So for example, if you're deploying a virtual machine, maybe you want to know the host name and the IP address. So that's what you can define there. Okay, there are multiple providers. You can find them here. So this one is Google, but you can find other providers as well. And basically what it does, it's giving you the resources definitions. So behind this, you know, the provider is actually doing all the automation for you. So you just declare what you want to deploy, what's actually the final state, because it's more declarative, they're imperative. So you declare the state, and you know the provider is actually taking care of applying this to the environment. So you don't really need to bother about how this is done. You just want this state to be done. Okay, state file and logs. This is pretty important when you start working with multiple developers or DevOps guys. So you do define for, in particular for Google Cloud, the state can be stored on Google Cloud Storage. So basically that's the state file that sits there, and it's also locking the resources. So whenever there is some action, when someone is running Terraform apply, it would actually check the state of that particular resource and allow to change it only if there is no lock on it, right? There are multiple possibilities for the backends. We're using GCS or we're using Google, but for Amazon, you can use S3. Or, you know, for other providers, you can use different way of storing your logs and state files. Okay, modules. So this is very similar to functions in any programming language. So basically, it allows you to store multiple resources. So let's say you want to have a virtual machine, multiple virtual machines with load balancer. So you would define that in the module. So you would create a module using, you know, resources for virtual machines and load balancers. You'll put it together, and then you can call it from your template. And those modules can be either local, so you can store it locally in subfolder where you store your Terraform templates, or you can store it, you know, somewhere on a repository. So they can be used by multiple people. Okay, Cloud Foundation Toolkit. This is really cool stuff. So Google has developed multiple templates. They started with Deployment Manager, but now they are also working on Terraform. And as you can see, you know, there are a lot of commits in GitHub right now. So this is, you know, being updated very often. And, you know, they have already 45 Terraform modules. And this is basically giving you a lot of templates that are done according to GCP best practices. So I really encourage you to Google that, and you can see Terraforms for deploying projects, for deploying VPCs, for deploying all the objects that are, you know, in line with GCP recommended security postures. Okay. Now we're going to have a simple demo of Terraform deployment. So I give the floor to Tomasz to present us with it.
Thanks, Konrad. So let's start by installing the Terraform. Terraform can be found on terraform.io. In the section download, you can find it for different flavors of your OS system. And there's also getting started section where you can find the tutorial how to install that. It's pretty straightforward, but if you do it for the first time, you can find some help over here. What I'm going to do, I'm going to utilize the Google Cloud Shell where the Terraform is already installed. Let's verify that. We've got that in version 0.12. Perfect. My folder is empty, so let's open Cloud Editor, create a new file. Let me call that main.tf. .tf is the default extension for Terraform, and let's specify the provider. The provider I'm going to use is Google, and I'm going to specify the project on which I'm going to work, which is devfest-tom. All right, that's it. What we can do right now is to initialize our Terraform environment with Terraform init. It will download the provider, make sure everything is all right, and we've got a success message. All right, so let's create some resource. The first one I'm going to do, I'm going to create a VPC network. For that, I'm going to use Google Compute Network, VPC network, specify a name. Let's call that Devfest network. And that's pretty much it. What I can do right now is execute Terraform plan to see what will be the plan of the action. As you can see, one resource would be added, which is VPC network called devfest-network, and Terraform apply to apply the changes. I can review them again. If everything is okay, accept that with yes. And the VPC network is being created right now. As you can see, it takes less than 1 minute in my example. And if I navigate back to Google Cloud Console, to VPC networks, we can see that besides our default network, there's another one created called Devfest network. So that's pretty awesome, right? Just 7 lines of code and we've got our VPC network. There's also Terraform TF state file created, which hosts the state of our Terraform deployment. Terraform state can be kept locally or, for example, on the Google Cloud bucket. All right, let's do something more fun. Let's create the VM instance. I will call that VM1, specifying the name, machine type zone, boot disk with the image name, and also the network interface. The network, I'm not going to use the name. Rather, I will specify the reference to the object I already created. This is pretty cool because that will create the dependency that my VPC has to exist before the VM can be created. Let's apply the changes. As you can see, we do have one object to be added. That's our VM instance. We can review all the changes. And once accepted, let's specify yes to accept the changes. And the VM is being created right now. After around 15 seconds or so, the VM is created. So let me navigate to the Google Cloud Platform, to Compute Engine VM instances, and let's verify that. All right, there's our VM called VM1 with internal and external IP address. Everything seems fine. You can also modify your resources by changing the file main.tf. So in this case, I will add startup script that will install Nginx. To apply the changes, I will execute Terraform apply again, and it's important to understand what will happen. In this case, this change requires to recreate the VM, so the old VM will be replaced with the new one that will run my startup script and install Nginx web server. Let's accept the changes. As you can see, first the VM is being destroyed. Once it's destroyed, a new one is being created. So let's verify the changes. Let me go back to my VM view and refresh the page. There's a good chance that the IP will be changed since that's the different machine. Let me copy the external IP address. And if we try to access our web server, it will fail because there is no firewall rule that allows port 80 to be accessed. So we can add the firewall rule creation to our Terraform template as well. For that, I will use resource Google Compute Firewall and create a rule that allows HTTP traffic. Let's call that allow HTTP on our network. Again, instead of specifying the name, I will reference to the one we created previously. So that's the one. And let's create a allow section with protocol TCP and port 80 for HTTP traffic, right? Okay, the allow section is okay. Let's specify for who that will be opened, I will add the tag called web, and yeah, my resource definition is all right. So let's apply the changes. Again, in Terraform apply command, we can review the changes before we accept them. As you can see, one resource will be added, which is our Google Compute Firewall rule. Let's accept the changes. And after a couple of seconds, the rule is created. But there's one more thing we have to do. Since the rule applies to all the Google Cloud resources with network tag web, we have to make sure that our instance have this tag assigned. So let me add the definition of the tag, tags, and specify just one web. So that will modify our VM. Let me go back and again apply the changes. This time, since we just adding the network tag, it will not require VM creation. The whole changes will be done in place, so the VM will be online all the time, nothing will change. The only modification will be adding the web tag. So let's apply the changes. And after a couple of seconds, the changes on VM should be applied. And once this is done, our web server should respond. So let's verify that right now. Let me navigate to the tab with my web server, refresh, and we can see welcome to Nginx start page. One of the beauties of working with Terraform is that we can create everything with like single command and destroy everything with single command. So in this case, Terraform destroy, we can review what will be destroyed. We've got three objects, which is VPC network, VM, and firewall rule. If we apply the changes, notice that first the firewall rule and the VM instance is being destroyed. Once those two will be destroyed, then Terraform will also destroy VPC network. The order is important, and Terraform keeps track of it thanks to the dependencies. If we would try to delete the VPC network when it's being used by the VM, it would fail. So let's verify the changes. The VM instance doesn't exist anymore, and if I navigate to VPC networks, I can see that only default network exists. The one we created is destroyed. We can deploy the whole environment again with just single command, Terraform apply. We can review the changes. All three resources will be used. And since the dependencies were specified, Terraform will create them in the correct order. And after a minute or two, we should have all our resources up and running again. So hopefully that was a nice demo to show you what is possible with Terraform. Thank you.
Okay, thanks so much for this demo. It was really cool. Nice to see this in action. And now let's have a look at something which is called Terraformer, which is quite a nice tool when you start learning Terraform. And it's essentially reverse Terraform. So you take the objects that already exist in Google Cloud or any other supported provider, and you just run Terraformer, and it creates the Terraform templates for you. It was actually created by Waze, so you probably know it's a really nice application for traveling by car, to see the traffic and see some alerts. It informs you. It's kind of community. It informs you of all the problems that you might get on your road. So if you, and obviously it's not an official tool, but we find it very useful for learning Terraforms and sometimes, for streamlining the reverse Terraform actions. Okay, there are multiple providers. So there's Google Cloud, AWS, Azure, Alibaba Cloud, DigitalOcean, and actually something that's pretty cool is also that you have those for Kubernetes, and actually many more tools. So I encourage you to have a look at the website. And how this works, you simply install Terraformer. You can do it on Mac, probably on Linux it will be a different command. Then you import the provider. From Terraform. Well, you need to initiate your Terraform template to have the Terraform provider, but you also need to initiate the download of the provider for Terraformer itself. Okay, so let's go through this quick demo of how you would use Terraformer. So first, you actually need to initiate your GCP provider. So this is very similar to what you would do with Terraform. So we basically are just copying the provider information into the init file, and we run Terraform init. So this will initialize the provider plugin. This is successfully initialized right now. So we can start using Terraformer. As I was saying, we're now just importing the Terraformer GCP provider. Just copy those couple of lines in your terminal session. So this will be actually downloading some binaries as well. It takes a couple of seconds, so we speed it up. And now we can actually start downloading the resources, right? So we want to download the GKE resources from this particular project that we have here, but we also decide, okay, let's put on the resources for Google Cloud Storage as well. So we can edit in the resources, and as you see, the resources are being generated right now by talking to the GCP API. And on the left-hand side, as you see, we have already those templates created. So we can just go there, look at GKE. So as you see, the clusters are here. We have the container nodes. We have the output. We have the provider defined. So now we would actually be able to just take that, maybe some small modification if you want. Maybe you want to change the naming convention, but you can actually move this all to a different environment and simply just copy it, right? So it can be treated as some sort of backup as well. And here we have the state, so you can actually kind of copy, make a backup of your environment into Terraforms. Okay, so you see that was pretty easy to use. Let's come back to the presentation. Okay, and now let's have a look at Terraform testing and why would we want to test. And I give the floor to Tomasz.
Thanks, Konrad. So let's talk about testing. Why do I need to test? Just like in a software development, the fact that something compiles doesn't mean it's working. And it might be exactly the same story in infrastructure as code. The fact that you've got your Terraform code written that deploys different resources, different components, and creates your infrastructure, it doesn't mean that the infrastructure as whole will work correctly. It doesn't mean that each building block will work correctly with each other. And that's why you need testing. You can do that, of course, manually, but your infrastructure as code is going to be much of a living product, which will change in the future. And there are going to be a lot of different changes, some small changes, some added functionalities, etc. And to test that manually on each step might be painful. And that's why you can introduce automated testing. You can introduce them even in your CI/CD pipeline to make sure that with each commitment to your source repository, tests are run. So whenever there's an issue, you will catch them as soon as possible. Let's talk about type of tests. There are pretty much three types: unit, integration, and end-to-end testing. Unit tests are like testing the single unit, like the smallest piece of your code, the smallest functionality. For example, storage bucket creation. Integration test is testing couple of, at least two, units working together just to make sure that the cooperation is successful. For example, storage bucket creation and uploading files to that storage bucket. End-to-end tests are the most complex one, and they depend on the scenario. If you've got a workflow that utilize a couple of units that have to work together, that's a good example to create the end-to-end test for that. And all three types of tests, like unit, integration, and end-to-end tests, can be deployed or developed in Go language using TerraTest library. With TerraTest, you can automatically deploy your infrastructure, validate the infrastructure, and then undeploy it. So what will happen in the workflow? Everything that you want, for example, single unit for unit tests can be deployed. Then based on your design, tests or many tests can be run. Then the infrastructure will be cleaned up, so your resource will be destroyed, and then you will have your result. Either the tests pass or it doesn't. If it doesn't, you get the output what went wrong. And let me show you that on the demo. I will show you a simple unit test demo. For that, I developed a simple module called bucket with main.tf that utilize 4 variables to create a storage bucket. There's variables.df with the definition of those. 2 of them, location and storage class, have some default values. And 2 of them, bucket name and project ID, have to be specified. I also have a file called outputs.tf that will produce the bucket name once the module is deployed. There's also a folder called test data with file bucket.tf vars that specifies 2 values that will be used for my testing purposes. There's a bucket name and project ID. And there's also my automated test written in Go with definition of test my bucket function. As you can see, it has module location and test data location. There are different stages: to clean up, to deploy, and to validate. And the validation, I suppose that's the most interesting one. Having a unit test that just deploys the resource and then deletes that and doesn't check anything, it's not really a test. So in this simple example, I have a test to validate if the name of the bucket that was deployed is the same as expected. In this case, I've got the bucket 12, and in my definition, there's a bucket 1. So I suppose the test will fail, but let's check it out. Let me run the test and look closer at what will happen. The first, the Terraform is initialized, apply is complete, and then destroy is also complete. So we've got all 3 phases. Let me go it from step by step again. First of all, the Terraform initialize and apply is complete, so that's deployment. Then we've got our output and the destroy, so the cleanup is also completed. And at the end, we see what was the result of our test. As you can see, it's failed because the name expected doesn't meet the name required. So let me fix my test definition and let me change the name of the expected bucket name. And let's rerun the test again to see what will change. Since that's just a single bucket creation, I don't expect tests to run too long. And as you can see, again, the resource was applied, destroyed, and this time validation went okay. The result is pass because the name meets the required name. All right, so I hope with that simple demo, I gave you a taste of what's possible with TerraTest. There's an official GitHub repository where you can find quite a few examples if you want to try to develop your own tests. And I, of course, encourage you to do so. All right, so thank you for your attention, and let me go back to our presentation.
Okay, cool, guys. So that's been. I hope that's been very interesting for you to learn about Terraform. We are aware that in 40 minutes we can't teach you how to use it, but I hope you got interested in Terraforms and the use cases. We would encourage you just to follow up. You can use Coursera, you can use Quick Labs, plural sites. There's a lot of way to learn it, and also just YouTube it. There are a couple of really good tutorials. If you YouTube, you find Terraform tutorial on YouTube. There's a lot of really nice tutorials. And finally, if you want to learn a little bit more about Google Cloud itself, we really encourage you to have a look at this book. I'm the author of it together with my friend. It prepares you for the Google Cloud Architect exam, but it also It also gives you very, very good fundamentals of what GCP is and how to use it. Okay, thank you so much. If there is any time for question left, we can do it now.
All right. Thank you so much, Konrad Cłapa and Tomek Porożyński. So as I said, if you guys have any comments, feel free to leave them in the comments and they'll get to you. Next up, we will have Nirav Kothari with us today. Hi, Nirav. He is a solution architect with 16 plus years experience, and he'll be talking to us about building scalable LOT systems using GCP. So everyone give him your attention. Thank you.
Hi, everyone. Thank you so much. Am I audible?
Yes, we can hear you. You're all good.
Thank you so much. Thank you so much for this warm welcome. And I'm Nirav Kothari. I am working as a solution architect in Zurian Solutions. I am basically from Mumbai, India. And I'm also part of GDG Cloud Mumbai. I'm a co-organizer, and it's a big community. We have around 4,500 plus members in our community, and we are also parallelly organizing the same Devfest season in Mumbai and India. Thank you so much for giving me this. Opportunity. I'll move on to my today's topic. Today I'm going to speak on building scalable IoT systems using GCP. So here is what we can expect from my today's talk. Just give me a sec. Okay. So this is my agenda for today. I'll start with the market trend, and why one should, jump onto this particular stream of technology. What are the key challenges that people observe while implementing IoT systems? What are the different stages in IoT implementation, and as well as the pipeline? And what can we get from GCP services? So this is what I'm going to cover in today's topic, and maybe I hope that by the end of this session, it will create enough curiosity in your mind to start developing the application for application in IoT at your end. So let me start with some market predictions and the current trend which is going on. Looking at this trend, starting from 2017 to 2025, it is absolutely clear that the growth is exponential. That is specifically for IoT systems. Every system in today's world is going digital nowadays, and you are seeing the all over development. Digitization in all the areas. Okay, so it's a good time. We are still in the initial phases or initial stages of the development. I think we should, every developer or every organization should start looking into the IoT domain, because there is a huge potential out there lying out there in IoT domain. Just to give you a quick glimpse of there are around at least 6 to 7 devices per person in this world which is connected to internet. Okay, and this growth is continuously increasing. There are around 127 devices getting added to the internet every second. Now, looking at this, you can assume, you can just guess what is the potential in IoT systems. Moving further, if you look at, so this is basically industry-wise distribution of IoT market cap. You are seeing growth in all of these sectors, and majorly you can say that the industrial IoT is being the most common. So every industries, manufacturing industries are going digital day by day. Okay, so there's a huge potential out there. Not just industrial IoT. If you talk about transportation, mobility, supply chain kind of applications, that is also becoming digital nowadays. Talking about automated warehouses, or maybe tracking of your trucks if they are going or delivering goods from one location to other. So you would see IoT application in those applications. You would find IoT applications in energy sector as well. Let's say if you might have some kind of renewable energy, something like windmill energy. Windmills, basically energy generator, lying at a very remote locations. So you can to check the health or the monitor such devices remotely, you need some kind of IoT systems. Talking about retail sector, you have be it automated checkout, or maybe smart cart, or say for example applications like as you move down the lanes of the mall owner will keep on pushing interesting promotion offers to your mobile just by tracking your position in the mall. So there are endless applications, endless thoughts that can be developed using IoT. There are smart cities also nowadays booming up. So be it your e-surveillance, or maybe it could be smart traffic controllers, or it could be anything which is making your city very smart. So it's finding applications there. It's finding applications in healthcare, agriculture, smart home. So that has become quite common nowadays. So you would find endless applications for IoT. So it's a good time for even developers and organizations to jump onto IoT, and for a bright future. Moving on, let's say if you decide to get on to start on basically developing IoT systems, you actually encounter these 4 challenges. Okay, when you talk to any client, he would be most worried about the security of that data. Okay, so these are the usual challenges that you observe when you start implementing the IoT systems. So security, second connectivity. Connectivity in the sense, say for example, if you have a system which is, say for example, truck tracking system. Now it may go in an area where there is no network coverage. So in such scenario, your truck may not be able to send current state or current signals to your IoT systems. So in such scenario, you need some mechanism so that even if there is no connectivity, your IoT systems should not fail. Another challenge is basically dynamic scaling, because usually whenever you start with these IoT systems, you start with very small set of application or some small set of use cases. And as you get more and more successes, you start delivering this services to multiple customers. They start encompassing the same application to the multiple devices and all. So you need to have dynamic scaling in your IoT system. Specifically for IoT, dynamic scaling is very much important. Talking about actionable insights. So basically, IoT systems are basically meant for bringing in all the data from remote devices. Now, what are you going to do with these data? You have to have some kind of meaning out of that data, okay? Which means that you might want to observe these systems, you might want to control these systems, and that's what we call it as actionable insights. So by looking at the data which is coming in, it automatically takes the actions And that's what we call it as actionable insights. So these are the 4 things which is most important in IoT systems. Now let's go further and explore what are the stages involved in implementing IoT systems. So basically, these are the 5 stages that you have to tackle while implementing IoT system. When we talk about acquire usually means you deal with sensors, which actually senses the parameters based on your system. Usually these sensors are domain specific, okay, and usually they are different for different type of applications. In this stage, you usually work with encoding of the data. You work with multiplexing of these data. You also work with data compression, because if your sensors are measuring data at a very high rate, but you don't want to record these data at such high rate, or maybe you don't want to utilize your bandwidth so much, you may you may look for something like data compression in your application. Okay, now acquire is that stage which you usually implement it at the actual site where your actual devices are, okay? Whereas all other stages are usually built on cloud, okay? Now, when we talk about ingest is the first stage in your cloud system, okay? And that's why we call it as ingest. Usually it compasses of some kind of gateway, so that various devices from across the globe can keep sending the data to your cloud system. So that gateway should support multiple protocols, because some devices might send in some sort of protocol, and some other devices might follow some other protocol. So your gateway should support multiple protocols. Usually in IoT systems, usually there are 3 protocols that is followed, which is HTTP, another one is MQTT, and the third one is AMQP. Now, your IoT system that you build usually follow these kind of protocols. The purpose of this ingest is basically collect data from various systems, various devices, and then distribute it to the further system in your pipeline, IoT pipeline. At this level, since it's an entry point to your system, you also have to worry about the security of your data. Okay, so it has to follow some security norms, so that no malicious code or no malicious application or human sends incorrect or some data which to fool your system. Okay. Apart from that, the next stage in the IoT pipeline is basically processing. Once you have ingested your data, you would like to process that data. Process in the sense, usually this processing is aggregating your data, transforming your data, based on your application or based on your following system. You might want to transform the data before it gets stored into the system. At this stage, you are also worried about streaming data, which is coming in through this ingest pipeline, and many times it may happen that you might want to upload data in batch fashion as well. So your process stage should support streaming as well as batch. I'll give you one example of where batch kind of data would be really required. So as I was talking about the previous case where he said that you might be having a system which is tracking your truck's position. Okay. Now there are chances that it may go in a place where there is no network coverage. Now in such scenario, should we lose all the data during that time? Of course not. So your system or your devices should keep storing those data locally if there is no network coverage. And once it comes back into the network area, you again send those data in a batch fashion, or you upload these data to your cloud system in a batch fashion. So that's why you need a batch plus streaming solution in your IoT pipeline. Okay, Once you have, pipeline, your data processing is done, you would like to store that data in some sort of data warehouse or maybe some sort of databases. And, depending on your application or your requirement, you can choose various data warehouse or databases. Once the data is in your data warehouse or database, you would like to, have some sort of dashboards showing the current state of your IoT systems. Not just that, you might want to, do some sort of analytics on top of your visualization. Okay, and that analytics should eventually lead you to some controlling actions. So these are the 5 stages usually involved in building the IoT applications. Now, if I want to implement it locally, I would have to build right from beginning, and so many components are involved in this, and which is not going to help me, or it will take a lot of time for me to implement all these components. And that's why people usually rely on cloud services to implement these kind of applications. But which cloud service should I use? So the question is, what cloud should I use to implement my IoT pipeline? And the answer is GCP has all of these functionalities, all of these services to implement each of these stages. Now, here is the quick glimpse of what applications we can use, what services we can use in each of these stages to implement this IoT pipeline. There are IoT Core, IoT Cloud Storage, BigQuery, Data Studio, and there are multiple. Okay, so I'll come to each one of these in the next slide. But the point is, GCP provides most of these services to implement IoT pipeline. Now, this is a complete architecture of IoT-based application using GCP. Don't get scared with the so many services or the complicated diagram. I'm going to take you through each one of these blocks so that you understand this pipeline completely and you start implementing it on your own. Okay, so moving further, taking the first step, which is usually the sensors. These sensors could be at any location. It could be at windmill. It could be at a smart home building, or it could be at a vehicle, or it could be at your offices or any factory. Okay, so usually these sensors sense the respective parameters as per your domain, and once it has sensed this data, it has sensed this data and it sends this data to cloud system. Now, as we talked in the last time, that you need some kind of gateway to collect the data from all of these devices, and that gateway in IoT systems is nothing but this IoT core, cloud IoT core, which is a gateway to your IoT systems, IoT cloud systems. It provides you, the security. It provides you device provisioning. It provides a mechanism to control your devices. It provides a mechanism to collect data from all these devices and then distribute it further. So it collects the data from these devices, from these sensors, and then gives it to something called as Cloud PubSub, which is nothing but a messaging queue for GCP platform. So any data that comes into IoT core will be published into Cloud PubSub, and eventually whatever services are subscribing to your PubSub or to that topic will get that data. Now, on the other side of the Cloud PubSub, we usually connect Cloud Data Flow, which is nothing but the third stage in our pipeline, which is processing. So here we process the data. We process in the sense we transform the data, we aggregate the data, and we format the data before we store the data inside your database. The database that we are selecting over here is basically BigQuery, and BigQuery is basically a huge it's a managed, fully managed data warehouse service provided by GCP, and it can store a huge amount of data. Once you have the data in BigQuery, you would definitely like to visualize this data. Okay, to monitor what kind of visualization you can have. You can have real-time dashboards. You can have historical visualization of the data of your devices. You can, or even have dashboard which is aggregating data over multiple devices, so it can aggregate and show it to you. So basically, this is the front screen for any users. Okay, so they get to know what is going on behind the scene. So this is the application where the most of the end users work. Okay, and rest of the other blocks that you see are basically the backend to them. Okay, so Data Studio is not the only application which provides the analytics or business analytics. You can attach your own third-party tool. It could be ClickSense, it could be Tableau, it could be even Looker. Okay, so you can select a business analytics tool as per your choice. And once we are, once we have the data in BigQuery, we would also like to, do some kind of machine learning. It could be a use case, where people would like to do some kind of predictive maintenance or predictive analytics. Okay, so in such scenario, you can build your own model on GCP itself. Since the data itself is lying inside your GCP platform, you can build your machine learning models on top of that, and you can derive some meaningful insights from that. Now, this was all about how the data transfers from devices to the cloud. Okay, which I call it as left to right. Now, there are scenarios when you would like to transfer the data from right to left, which means that we would like to control your devices. Now, devices in the sense, it could be your sensors or some devices which consist of sensors. Okay, so you might want to control these devices from cloud. Now, let's look at that flow. So, you might start with machine learning models. After your predictive analytics, you might end up with some conclusion saying that I might want to turn off a particular device. In such scenario, this inference is basically processed by our processing engine, which is again the cloud data flow, which is a processing engine which can read data from multiple places and take the corrective action. So data flow will pick the machine learning predictions, and through cloud IoT core, it will send the necessary controlling signals back to your devices. Now, the controlling signals could be something like turn off a device, or say for example reduce the speed of a rotator, or set the temperature. It could be anything. Okay, so you can actually control these devices in automated fashion. Now, there are scenarios when you want to have a scheduled controlling of the devices. Now, it could be say for example say on Friday evening, I want to switch off the thermostat of my office building. Or say for example, every night I want to turn off a particular device. Okay, so in such scenario, you can actually schedule your schedule the task, and through cloud functions, you can send those messages through cloud IoT core to these devices, and eventually your devices can be controlled in scheduled way also. So for automated control, you usually follow this path. And for scheduled control, you usually follow the path of cloud functions. Talking about this cloud storage, as I mentioned in the previous slide, that you might want to upload offline data as well. So in such scenario, you might upload offline data in cloud storage, and your cloud data flow can pick up the data from cloud storage and apply the same transformation, same aggregation as the your online data. It can apply the same transformation on the offline data as well, and then store it in your databases. Moving on, in some scenarios, now on the right-hand side, you see our normal pipeline in the cloud. On the left-hand side, what you see is basically the sensors. Now I have attached something called as edge device in between. Now this edge device is basically some processing engine which is usually placed at the site also. So along with your sensors, you also deploy edge devices at the site. Okay. Now what's the need of that? Now, in the previous slide, we said that if your predictive analytics provided some inference and you want to control the devices from cloud, then in that you can follow that pink path and control the devices. But many a times what happens is if you want a quick response, so for example, if you are building a autopilot car, okay, and if you get some obstruction in your driving path, it cannot wait for it to send the images to the cloud. Then cloud may analyze it and take the decision that it has to put a brake and then send the message back to your edge device, basically the controlling device, and then put a brake. It cannot wait till that time. So you need to have some mechanism to have your controlling mechanism at the site itself, and that is the requirement where you would like to have some kind of edge device which has its own processing capacity to sense and control right from there without even consulting the cloud services. And that's why you need the edge devices. Moving on. So basically, when we say edge devices, you are actually converting your sensors from just the data collectors to real-time decision makers. Now let's go into the each of these blocks very briefly. Let's start with the cloud IoT core, which is the main building block of IoT system. So it basically consists of these 5 blocks. First one is basically MQTT or HTTP protocol bridge. Basically, it's a protocol bridge. So any devices usually connects to your cloud system through this block. Basically, it's a bridge between your devices and your cloud system, and it supports multiple protocols, and that's why it is called as protocol bridge. In GCS, basically in Google Cloud, it supports only these 2 protocols, which is HTTP and MQTT. AMQP is not supported. Apart from this protocol bridge, it provides a mechanism to provision your devices. You can configure your devices. It provides a mechanism to authentication and also basic monitoring, like how many messages are coming in, the rate of messages, how many messages are going out, and stuff like that. And also it has a data broker which acts like receiver and collector and distributor. So it collects the data which is coming in from devices and gives it back to downstream, which is cloud pops up. Now this whole cloud IoT core is basically it consists of auto load balancing. So you don't need to worry about the if you're scaling up your application, you don't need to worry about it. It's an auto scaling system. I talked about device authentication. When we talk about authentication, there are 2 stages. Okay, usually you would like to have some sort of device provisioning. Device provisioning. So basically, when you are configuring a device, you are actually focusing on device provisioning. And when you are actually sending the data, you are actually focused on device connection. Okay, so device provisioning means a person who is actually configuring the device. Okay, so what he does is basically he creates a public key private key pair, and it sets the public key inside your IoT core, and sets the private key inside your device, the sensor. And so this is set. Now anytime the device wants to connect to connect and send the data to cloud, it follows the device connection flow. So what it does is basically it creates a JWT token. This is specifically for MQTT protocol. It creates a JWT token which is signed by the private key that was stored earlier, and it sends a connect request to your MQTT bridge, and it verifies that JWT token using the public key that it was stored earlier. So once it verifies it, and then it says that it is connected, and then onwards it does not have to send all the authentication parameters again and again in every request. Once it is connected, it can keep on sending the data. So ultimately your overhead of sending the username, password every time is offloaded basically. Now, talking about the second block of our pipeline, which is Cloud PubSub. Cloud PubSub is nothing but a publisher-subscriber messaging platform. It connects multiple publishers to multiple subscribers. It is basically a many-to-many relationship. So you decide a topic, there will be multiple publishers publishing to that topic, and there will be multiple subscribers who could receive from that topic. This particular system, this particular service from GCP ensures that it will have at least once delivery. Okay, and it also has buffers or basically the memory inside that, so that even if your subscriber undergoes any kind of outages or it's offline, it will store the data which has come from publisher for certain time inside your system, and it will deliver whenever the subscriber comes up again. It supports push and pull both mechanism, and there are number of rich client libraries available in every language to connect to PubSub. Well, we are developing this whole application inside your complete GCS parameter, so you would not need to connect through client libraries, but just for your information. Now, the third stage that we discussed was basically data flow. Data flow is basically a end-to-end your data transformation pipeline. Okay, it can take in data which is coming in through streaming. It can take in data in batch fashion from your multiple sources. It could be your databases, it could be your Google Cloud Storage, okay, or any, for that matter, any Google Cloud services. It can pick up data from that and apply the same set of transformation logic on both these type of data, and apply the processing on that. For example, filtering of data. For example, grouping of data, or it could be something like windowing function. So if you want to aggregate the data over a particular window, so it provides mechanism to window it, and then you aggregate the data on top of that. Even this service is basically completely serverless and auto scaling. It provides notebook integration, so that you can quickly experiment with your data. You can apply some transformation logic and quickly verify the results. Okay, it has inbuilt some of the templates, so which are usually used or usually sought after transformation logic. So those templates are already saved in Dataflow. So it's quite easy to implement your transformation logic using Dataflow. Moving further, BigQuery, you all know it's a enterprise enterprise data warehouse in Google Cloud Platform. It provides you, the standard. It allows you to query your data using standard SQL, and you can actually store, huge data. It can, store petabyte scale of data, and even if you try and query those data, the response is very fast, because BigQuery is specifically meant for those kind of purposes where you have huge amount of data and you want to query the data quickly. Specifically, this is a requirement for cases where you have some sort of BI or BI tool, okay, business analytics tool on top of that. So in our IoT applications, usually you have some sort of analytics tool or some sort of dashboards. So BigQuery plays a huge role in this scenario. It's quite secure, it's durable, it is highly available, it is fully managed, so it can scale also to any data that you have. So moving on, the last part of our application is basically Cloud ML, or recently it has been renamed as Cloud AI Platform. It's a service to build, test, and deploy your machine learning models inside the Google Cloud Platform. You already have your data inside Google Cloud Platform in terms of Google BigQuery. So you can utilize Google Cloud AI Platform to pick the data from BigQuery and build your model on top of that. It's a very exhaustive platform where you can build any type of machine learning model. It has support for TensorFlow and many other machine learning libraries, so that you can build right there and test and also deploy also. Okay. It's a very extensive platform where people, if you have a huge team, lot of people can collaborate and provide their code and deploy their machine learning models. So it supports a complete life cycle of the ML models, because when we talk about ML models, it means that you are reading the data, you are processing the data, you are basically pre-processing the data, you are training the data, you are predicting the data once it has been deployed. So it needs a lot of things, and this platform supports everything. Again, it's a fully managed, scalable platform and distributed service. So you can apply multiple devices, multiple VMs who can process for your training and stuffs like that. Also, one of the good or the most sought after feature that it provides is basically automatic hyperparameter tuning. So it speeds up your implementation. Now let's review again the challenges that we talked about at the start of this session. We see that security. Now, definitely, this whole system is completely secured, because every services in GCP is encrypted. Your data is encrypted at rest as well as in transit. Okay, when you're storing the data in BigQuery, your data is encrypted there. When you are sending your data from your devices to this IoT hub, so there also you are actually basically encrypting the data and then sending it. So security is definitely automatically covered in this system. Talking about connectivity, as I said that you would have batch as well as the streaming way of processing the data, and that's why even if you're going under outages for a certain time, you can actually you can take care of the connectivity issues as well. Dynamic scaling, all of these services that I talked about are actually dynamically scaling. So you don't need to worry about upscaling your application and all that. Actionable insights, yes, you need two type of systems for that. One is basically your BI analytics tool, and another one is a machine learning capacity. Now, GCP gives both of this method, and that's how you can actually effectively manage your data, manage as well as monitor your data and systems. So GCP provides all. Moving further, that's all that I wanted to share. I think I am right on time. If anyone has any question, I am ready to take that up. Or these are the handles that you can connect with me on. I'm quite active on LinkedIn, Twitter, as well as on Medium. So you can refer to these social handles. Thank you so much. I would like to, with this, I would like to thank GDG Poland team to giving me this opportunity to speak at this this platform. Thank you so much.
You're very welcome, Nirav. Thank you. Okay, hello. My name is Eli, and I'm going to be your moderator for the next 2 hours. And our next session will be run by Konrad Cłapa and Jaroslav Gajewski from Anthos. They will be talking about developing with Anthos, which is the tool that helps developers focus on development and takes away the hard part of learning Kubernetes.
Welcome to our presentation of Devfest 2020. My name is Konrad Cłapa, and I have Jaroslav Gajewski with me. Today we're going to talk about how Anthos is making it simpler for you to develop application on top of Kubernetes. Okay, so our agenda for today, we're going to talk about running cloud-native workloads, what Anthos is. We will have a look at different components of Anthos, and finally, we'll have a couple of demos for you to see Anthos in action. Okay, but before we start, let's have a look at who we are. So we're actually Google Cloud Breakthrough Partner. We work with Google very closely on a number of projects. Some of them are related to GCP as well. So those services that you see here, bare metal solutions, this is actually delivered by Anthos. So if you order a bare metal service from Google, it's actually running on our Bull Sequana servers. On top of it, we also have a database hotel. So if you want to run Oracle workloads on GCP, that's also what we are delivering. When it comes to numbers, so we are over 200 developers in Poland, many different places. Overall, Anthos is around 140K experts worldwide. And you can actually find us in many cities in Poland, including Bydgoszcz, which is the headquarters there. You can find us in Warsaw, Łódź, Wrocław, Opole, and Kraków. Okay, about myself. So what I try to do is to inspire people. I'm lead for a couple of communities, including GGG Cloud Bydgoszcz, where we meet and talk about Google Cloud. I'm also author of the book for Professional Cloud Architect exam. It's a guide that walks you through all the services of GCP and helps you passing the exam. When it comes to Anthos, I'm lead architect. I lead a couple of developers, and we develop products on top of GCP. And I must admit, I'm kind of certification junkie. So I have over 30 IT certification, and this is including all 10 GCP certificates. So some of my time is actually spent on learning new stuff. I love it. But when I have some free time, I do windsurfing. I love running and actually love getting things done. So basically, that's me. Okay, Jary, can you also say a couple of words about yourself?
Thank you, Konrad. First of all, I would like to thank you that you decided to spend that time together with us. I'm Nirav Kothari, and I'm lead technical cloud architect working together with Konrad in Anthos. I'm huge technology fan, and I love to spread my knowledge on the different community meetings and conferences. I'm also co-organizer of G2G Cloud Bydgoszcz, board game geek, and happy husband and father of 3. If you would like to reach out to me, you can find me on Twitter or LinkedIn. Konrad, I think now it's time to spread the word about Cloud Native world.
Okay, perfect. Thank you, Jarek. So let's look at Cloud Native. So Cloud Native, we might think of it as using containers, right? And using containers is not, it's simple for a developer. You just, define your dependencies, put it in a container, off you go. It works, right? And it should work everywhere. And the problem is that you really need to orchestrate that. You need to think about networking, you need to think about security policies and how you're going to monitor it. And there are many other things you need to think about on top of it. So if we look at this tweet that I really like from Kelsey Hightower, Kubernetes is a platform for building platforms, right? So it's an orchestrator, but you still need to have all the services around it to make it production ready, right? So it's not the end game. You're using Kubernetes to build platform. So here comes Anthos, right? You have this row. If you want to get those services, if you think about the services, there's so many open source. There's so much open source software out there. So you can pick up from this landscape of Cloud Native. It works, right? It's perfect, but it's not ready for production. So if you want to make it production ready, you need to put it all together. And it's quite some work that Anthos is actually delivering the services for you already. Okay, so let's have a look at Anthos, what it is. So this is a definition from Google, which we really like, so we didn't want to really modify that. So let's see. Anthos is a managed application platform for enterprises that want faster modernization and great consistency in a hybrid and multi-cloud world. And this is a perfect definition of what Anthos is. So it's fully managed, right? So it's managed by Google. You have the SREs taking care of the control plane for you and making sure that the service is running. It's application platform, right? So it's based on Kubernetes, Istio, Kinetic, Tecton, all those services that make an application platform. It's enterprise ready, right? So it's built on it's built on the experience coming from production, and it's building all those services around it so that you can deliver the service in a production ready manner. It provides modernization, so things like migration from virtual machines to containers. This is provided by Anthos Migrate as well. It provides consistency, so you have configuration management, you have policy management. So the configuration of your Kubernetes cluster is unified between different environments, and it's hybrid and multi-cloud. So it works on premise and it works on all the major cloud providers out there. Okay. Anthos architecture, what it actually does. So let's have a look at the bottom. So you already have your storage or compute network provided by one of those platforms, whether it's Google Cloud, other public clouds like AWS, Azure, and this is actually including also the managed Kubernetes offerings like AKS, EKS, on-prem, which is currently VMware, but it's going to be extended as well. Bare metal. So pure without VMware, you can run it on-prem, you can run it on edge devices as well, and bring your own Kubernetes. So you can actually import existing Kubernetes environment and get it under the management of Anthos. And what it actually offers you, right? It offers you environments. So you can gather different various Kubernetes cluster into environment where they're going to be managed in the same fashion, right? So you can create multiple environments, but you can use on each of those environments, you can run you can manage it using different services like configuration management. So you have consistent configuration like names regarding namespaces, role-based access controls, etc. You have policy management, which allows you to set what's allowed and what's not allowed on your Kubernetes cluster. Service management, including traffic management, fault injections, observability of your services, securing the traffic, and of course container management, which comes with GKE. On-prem, on any other cloud. So this is being extended as we look. We already have AWS, we have Google Cloud with Azure coming. And on top of it, obviously, you have this management plane where you can see all your cluster in one place in a single pane of glass. And you can also have the observability. So basically, you pull all the logs together. You get this. You might get the statistics from the service mesh, see it all in one place, and manage it from one place. Okay, short history. So how did it start? So actually, if you look at 2014, this is where Kubernetes was open sourced, and Google came up with the GKE. In 2018, it was a big thing. No one knew how it's going to work with GKE on-prem, but it was announced. We knew that it's going to run on VMware. And at Next 2019, Anthos was announced. It was a massive thing. It was still not very much unknown what it's going to deliver. But we're in 2020, and we already know there are so many services around Anthos that we can already use in production. Okay, where can I run it? So we've been talking about this already, but you can basically run Anthos almost everywhere with Azure also coming into the play. But you can basically either deploy GKE on different cloud providers, or you can import your Kubernetes cluster and manage them under the Anthos management plane. Hey, what is it for us? Having Anthos, you can think about Anthos as one-stop shop, right? So you order Kubernetes cluster, you order service mesh, add-ons, you can enable Cloud Run on top of it. So without the hassle of installing all this, you can just order it from the Google Cloud Console or using CLI, and you have it all running, monitored. You have the logs stored in Cloud Logging. So it's basically a one-stop shop where you can buy all those services. Okay, now we're going to have a look at Anthos GKE on-prem, which is quite interesting. And I give the floor to Jary.
Thank you, Konrad. So as it was already mentioned, 2 years ago, Google introduced GKE on-prem. The key difference between GCP implementation and on-prem implementation relies on the responsibilities. In GCP, you can just spin up your new cluster and take care of configuration and application deployment on top of that. In the on-prem, the responsibility is significantly bigger. First of all, we need to take care of the physical hosting, networking, and storage that will be used by our Kubernetes clusters, hardware, and operating system for our hypervisors. In the identity management area, Google provides us capabilities to integrate into existing identity providers like Google, IDFS, Okta, and so on. Google also introduced for us or provides for us the Kubernetes and Istio binaries that are tested by them and versioned properly. They also provide for us the base image for our Kubernetes nodes that is Ubuntu based and proper hardened. Similar to GCP, we are responsible again for the configuration of the clusters and deployment of the application on top of that. When we will start describing GKE on-prem, we can say that it's split into two key areas: management plane, control plane, and the user plane. In the management plane, we've got admin workstation and admin cluster that take care of lifecycle management of our components, that exposing Kubernetes APIs for our clusters and taking care for the certificate management. When we've got admin cluster ready, the user clusters can be spin up. We can have single or multiple user clusters. They can be separated on the compute, storage, and networking area. To install new GKE on-prem, first we need to prepare the GCP project, so our environment, as Konrad already described. We need to prepare the service accounts and the binaries. When it's ready, we can deploy our admin workstation. That is just a virtual machine with the proper toolset on top of that. Then we need to deploy our admin workstation, admin cluster. Admin cluster can be integrated into existing load balancers, or we can spin up CISO as an integrated load balancer. After that, we can deploy our user clusters. Some of the configuration of the user cluster need to be decided before we will create it, like Clouds Run or the load balancing configuration. Others can be configured when we are ready and our clusters are up and running, like configuration management, service mesh, or policy controllers. When we will describe how it's working, we can say that on each cluster, we've got Connect agent that is responsible for communication between Kubernetes API and Connect proxy located in GCP. The architecture is exactly same for on-prem, GCP-based, or any other Kubernetes implementation that we would like to
Welcome to our presentation. Welcome.
As soon as we will test everything in development, we can push same updates into our master branch. So let's do so. Let's merge it from the development into the master branch. Let's submit the merge request and approve it. At the same time, in theory, in the backend, our changes should be recognized and applied. Now we see that both clusters were synced in the same time. That guarantees for us the consistency. Let's come back to our Kubernetes cluster back. I've mentioned that as soon as our clusters are part of our GCP console, we can leverage existing Anthos capabilities. So, for example, we can deploy from marketplace applications to our clusters without interacting directly with them. To save the time, we will not do so, and we will just create few deployments to present the basic options. So we will deploy Nginx container that will be exposed in our AWS attached cluster. As soon as it's ready, we can leverage AWS capabilities and expose our new service through EKS load balancer. That will take a while to configure it. We can see that address is already assigned for us. Let's validate that it was properly exposed. The removal process looks exactly the same, so we can just remove the container from our console. Okay, that was all what I was intended to present you during that session. Moving back to Konrad to talk about serverless Kubernetes. Thank you.
Okay, thank you, Jarek. And now let's talk about serverless Kubernetes. So what is actually serverless Kubernetes? So, you know, you probably used to use function as a service, but it's a little bit more. So as any other serverless Kubernetes, offering, it actually doesn't require you to manage underlying infrastructure. However, it's multi-language. So there are many languages that might not be supported by function as a service offering, but you know, it really very much depends on you, what you put in the container. So enough, you create a container, you expose the service via HTTP, and you can just use it as any other function as a service. It's event driven, so it's triggered by events. It's auto scaling, so you really just set up the auto scaling settings you want to be applied to the service, and it auto scales for you. And it's very portable. As it's running on Kubernetes, it can run anywhere on any Kubernetes environment. Okay, and how this is done? So there is a project called Knative, open source project, and actually Google made a managed service out of it, which is Cloud Run and Cloud Run on Anthos. So Cloud Run is fully managed. You don't really need to think about your infrastructure, and Cloud Run for Anthos gives you a little bit more flexibility. So you can install it on-prem, you can install it on any Kubernetes, any GKE cluster, whether it's GCP, AWS, or on-prem. Okay, and actually Knative came up with 3 components, serving, eventing, and build. The build actually has been such a big project that it was moved into Project Tekton, so it's mostly about how you build your containers, helping you to containerize your application, while serving is basically like exposing your service, and eventing is for creating different sources for triggering your Knative service. Okay, when it comes to serving, serving is actually an application running. All those components are actually applications running on top of Kubernetes. So in front we have service. You manage your application just using single object, which is service. That's where you define your traffic. That's where you define the version of your application, all the configurations, and all those objects are created for you. So imagine with a single YAML file, you can actually deploy whole your application, manage the traffic for it. So you can obviously do it with Kubernetes resources, but this is much simpler for you. And eventing is all about defining different sources. So it comes with multiple sources already, like GitHub, FTP, GCS. It can both actually use the push. So if GitHub, for example, is able to push the notification, that's fine, but it can actually pull from FTP, for example, right? So it knows if the endpoint is not available, is not capable of sending those events, you can do it as well. And that's why you have the adapters. The adapters are translating the events into cloud events, which is the open source format of events, and send it to broker. And you have triggers that can filter it, and deliver it to the service, whether it's a Knative service or Kubernetes service. Okay, and if you look at use case for it, so let's say you have IoT devices that are sending messages to Cloud Core, to Cloud IoT Core. So then they're sent to PubSub, and you have a source for getting this information from PubSub, and then they're sent to broker. We have a trigger, and then you can send it to a service. So obviously, this could have been done somehow with function as a service, but this is open source. This can run on any Kubernetes cluster. So it's giving you this additional availability on Kubernetes cluster. So it's very portable. Okay, and how would you run services now on Cloud Run on a managed service? So if you're a developer, you can actually use gcloud run commands. So you build your application with Docker file, you build it, you actually register those in a container registry, and then you can run it on Cloud Run. So it's all about defining. A container with HTTP endpoint, and you can simply deploy it to Cloud Run, and Cloud Run takes care of making sure that it can run properly on your on GCP. Okay, and there are multiple triggers right now. So you have a requester. It can be triggered from Cloud PubSub, Cloud Scheduler, Cloud Task. So that's the power of running it on top of GCP. That you don't really need to develop those triggers yourself. You have the triggers predefined. Just run your workloads, define the trigger, and there you go. Okay, there are also events for Cloud Run, something that was announced at Google Next 2020. And there are multiple sources right now. So you can define those sources, and for example, audit logging. So with audit logging, you can actually trigger Cloud Run, Kubernetes services, or just a URL endpoint. Any of the service in GCP can end up being a trigger for you. Okay, and now let's have a demo. So what we have done here we have this very common application, which is a boutique shop. And it's basically a microservice application. And it's running on Kubernetes, as you can see, but we kind of extracted it. So we have the payment service running on Compute Engine. We have all the other services running on Kubernetes, but we decided to run the front end on Cloud Run, which is serverless, right? So it still will be able to talk to other services and scale automatically based on our configuration. Okay, let's have a look at this demo now. So again, the front end based on Cloud Run, the payment service, we run it as a virtual machine. So we basically install the payment service outside of the Kubernetes cluster. So this is our instance running the payment service. Then we have GKE cluster that we deployed. And all the services, there is card service, there is cache, recommendation service, product catalog service, currency service, checkout, and email service. And this all is actually, well, the checkout service is talking to the payment service. Okay, and this is the Kubernetes cluster that we deployed the application to. So we see that everything is running right now. This is our cluster. And this is the Cloud Run service, which is the front end. We can access it from internet. We actually create a custom domain for it. So that's, you can see it from the console. You see there are a couple of interesting things in here. So the statistics, you can actually see the YAML file of the service, the definitive definition of that service. And now let's have a look at the application itself. Okay, so that's the boutique application, and it's actually running. So this is the front end that we talked to. Okay, now let's see. The front end is actually written in Go, running on Cloud Run. Let's purchase a product. So this catalog is actually running on Kubernetes. We go through the purchase. We buy 4 cameras. And now we can actually finish the purchase. We place an order, and you can see that actually this order is placed. It's a mock, but basically we place the order, and the order has been processed by a virtual machine, which is outside of the cluster. Maybe you know we have some specific reason why we want to put it on-prem because of some legal reasons. And here you can see the logs. So actually this Cloud Run service, the front-end service, is written in a way that it logs directly to standard output. So this is captured actually in Stack, well, previous Stackdriver, now Cloud Logging, and we can see it from the console directly. Okay, and now we will run some logs. So we're using this app K6 tool where we actually simulated a purchase order. So we simulated what the user would do, exactly what I have shown you just a couple of seconds before. So we're doing the same thing, but automatically, and we're generating a load on it. So as you can see, the front-end Cloud Run service is there, it's running. And it's only one. That's really interesting. Why do we have only one container? So we should have more. The reason for it is that the concurrency that we have set is 80. So basically 80 requests can be served by one container. So that's why it hasn't scaled. And, you know, it might be for a reason. If we see that, you know, the response time is okay, and we're okay with having one container serving multiple requests, because sometimes it might be even faster, and then we would do it like this. But now let's change from 80 to 1. So it would mean that every single container can serve only a single request. So this is fairly easy. You just go to the console. You could either use it from, you could either change it from YAML file, or you can change it from the console. So let's do it from the console. And there we go. It's very simple, you know. So the traffic already, well, the traffic is set. Okay, and we do the test again. Awesome. So we're making the request again, And let's see now how Clara went. So, okay, great. So we already see that as there have been multiple requests, we have new containers being set up for us. And as the traffic is pretty irregular with this application, so we can set it as you want, it brings new containers in. So you see multiple requests, multiple containers are being provisioned to serve the requests. Okay, so with this demo, we would like to thank you for today. And again, if you guys have any questions, please contact us on Twitter, LinkedIn. We're available there for you for any questions. Thanks again, and have a great day.
Okay, thank you very much. Hello, Paweł. Happy to see you. So,
hello.
I want to introduce Paweł to you. He's an experienced architect of IT solutions with AI, a CTO in the investment industry, and will show you the benefits of the advanced adaptation of cloud resources by using advanced forecasting methods together with machine learning. So, Paweł, the stage is yours. Take it away.
Thank you very much. Good afternoon. Can you hear me well? Is that okay, everything? Okay, I hope that you can hear me. So let me share the screen. Okay. And I hope you also can see my screen. Okay, that's great. Okay, so thank you. It is a pleasure to be here again because I was also presented last year, but last year it was the physical presentation, but now due to the current situation, it's virtual, but I'm very happy to be here and also to share some concept and ideas. And today I would like to say something about the proactive and polymorphic adaptation for the multi-cloud deployment. It is both concepts are very new. We are currently on the research phase and have some preliminary results, but it's still in progress. But I would like to share this concept because I think that it could be quite useful or even very useful for the applications. I will tell something a bit more in the presentation, but before that, I need to briefly introduce the melodic platform because this both concept, proactive and polymorphic adaptation, will be introduced in the melodic platform. So melodic platform is a universal platform for deployment and management application in the multi-cloud. It allows to deploy virtual machines, containers, big data stacks, and serverless components into the multi-cloud, and it also offers advanced optimization and reconfiguration of the application. And the very important fact, comparing to the other similar solution available, like, for example, Google Anthos presented on the previous presentation, it is vendor independent. Yeah, so Melodic is fully vendor independent. It was created as an open source project and is still developed as an open source project. Yeah, it's fully open source. And why to use Melodic? Because that's probably the simplest and most easy way to use the multi-cloud approach. As I said, it is possible to deploy virtual machines, containers, serverless components, and also big data. Currently, Spark is supported to different cloud providers, and the deployment is fully automatic. And even more, it is fully optimize. So that's the very unique element. The deployment, also the reconfiguration is fully done automatically, and it's also optimized in the very advanced manner. So that it's a quite unique thing, especially this optimization. And we are currently working on adding new features like proactive and polymorphic optimization. And the most important thing is that it's a fully vendor independent. The key element, I will also briefly introduce that, is the modeling language, which is a fundamental element for the Melodic. It is based on the CAML, Cloud Application Modeling and Execution Language, which could be seen as the extension to the Tosca, but it is the very significant extension because in this language it is possible also to model not only the infrastructure but also application components and connection between these components. We can also model the requirements, utility function, and thanks to that CAML could be translated to the mathematical form of the constraint programming model, which can be solved mathematically. I will tell a bit more later about that. So the very important thing and distinguish between the CAML and, for example, CloudFormation from AWS is that it is possible to define the application architecture, not only the infrastructure, and the requirements, constraints for each of the components. Thanks to that, we are able to find the optimal deployment plan for that application. And CAML fully support the multi-clouds, so Azure, AWS, and Google Cloud Platform are supported. Also, the OpenStack is supported. So Melodic is choosing the best optimal deployment for all of these cloud providers. The key thing of the Melodic is the optimization. Optimization means that the first optimization is done based on the initial parameters set by users. Then Melodic started to collect the metrics from the running application. It can be the technical metrics like CPU, memory, storage, and so on, but also business type metrics. So it is possible to define metrics like, for example, average user handling time, or average response time to the user, or average time of the processing given task. And these metrics are provided to the reasoning part, and reasoning part is continuously analyzing and optimizing the deployment. So it is possible to add or remove new resources, new virtual machines, new containers if needed, and to remove them if not needed. How Melodic knows what is the best deployment for the given application. And the first thought about the best deployment is that, okay, I want to have the cheapest one. It's the cheapest one deployment is to not deploy application at all. So it's simply not a solution. So usually the best deployment is some kind of the trade-off between the cost, performance, availability, security, and so on. In Melodic, we can prepare the utility function, which is very flexible, and it is some kind of the trade-off between these factors like cost, performance, availability, based on the metrics which are collected in the real time. The utility function is continuously calculated, and the application could be reconfigured. Of course, reconfiguration is not continuous. We have the threshold, and when the values of the metrics change by the given percentage threshold, like for example, the response time to the user is above the 20% above the average or above the defined value, then the application is reconfigured. But yeah, the new concept, because currently we can make a reconfiguration when the threshold is exceeded. So for example, the number of the response time to the user is exceeded. So we know that we start the reconfiguration, but the reconfiguration takes some time. We need to start new components, new virtual machines, and so on. So it simply takes time, and for that moment, the experience for the user with using the application is much worse than typically. So for example, for some kind of application like the e-commerce application, it could even cause that we start to lose customers, or customers will be unhappy, or so on. Yeah, so for that, we have introduced two new concepts. One concept is a polymorph architecture, because currently Melodic decides only how many resources should be used by the application, but we also want to introduce the concept of this polymorphic architecture, so Melodic could also decide what type of the technical resources should be used. Should we deploy application on the virtual machines with the GPU, containers, maybe on the serverless components. Also, we will have the support for the hardware accelerated resources like FPGA. Yeah, for example, for the machine learning application, AI-based application, if the model to train is quite small, it could be trained on the CPU, but if the model is bigger and the training data are bigger, then it is much cheaper to train the model on the GPU, even if the GPU, virtual machine with the GPU, is much more expensive in the cloud than machine without the GPU. So with this polymorphic architecture capabilities, Melodic will be able to select the best architecture for the given application. And the second concept on which I will focus more today is the proactive adaptation. As I said previously, currently, the adaptation in all of the cloud solution is done based on the current value of the metrics. For example, if you are using auto-scaling capabilities on the AWS, then auto-scaling is done based on the current values of the metrics. So if it based, for example, on the CPU usage, if the CPU exceeds certain threshold, then new resources, new virtual machines are deployed, but it could be too late. So it's already after fact. Our idea here is to provide the proactive adaptation, and for that we are using the advanced also machine learning based method for time series forecasting. So we try to forecast what to expect in the nearest future and reconfigure application based on the anticipated situation. So if we start to see that, for example, response time to the user is rising, then we can predict that it will exceed the threshold in, let's say, 10 minutes or 20 minutes, and we can start adding new resources beforehand. Thanks to that, it is possible to anticipate the increase of the usage of the application and provide the resources beforehand. Of course, the simple question is why not to, let's say, over provision or to have more resources all the time. The answer is also very simple. because it generates the costs. Yeah, for the big application, big deployments, the costs are quite significant. So using this proactive adaptation could save a lot of money. Of course, even if with this proactive adaptation, we could over provision, but by a smaller factor. Yeah, so we could have a over provision of the resources by 10 or 15%, not by the 30 or 40%, and the costs and the savings will be much higher in that context. And also it would be possible to better anticipate the usage of the resources and provide the better experience for the user. So how this proactive adaptation works? We have the initial deployment of the application, and for that initial, if it's very initial deployment, then we do not have any data about the application. We could have the historical data from the historical deployments and use that data to set initial parameters, but in all the cases, they are set initially. Then we start to collect the metrics from the running application, and if we collect enough number of the metrics, then we can start to forecasting future values of the metrics. If we have the data from the previous runs of the application, then we are using this data to make a forecast in that way. Then the optimization is based on the forecasting values of the metrics. So for example, we can predict that in 10 minutes or 20 minutes, the number of the user will exceed the certain threshold, or the average response time to the user will exceed certain threshold. So in that case, we are able to make a reconfiguration of the application. For the optimization, we are using exactly the same solvers as for non-proactive optimization. So we are using exactly the same solvers which are used in Melodic. We find the optimal deployment plan, but not for now, but for the forecasting future. And thanks to that, we have time to reconfigure the application. I hope that this concept is quite clear, because it's not a very advanced concept, but it's a very new thing. At least to my knowledge, there are no other solution which allows for that type of the adaptation. So how it works? Maybe show all of this screen. So the first thing is to model the application. We need to make a model of the application. We need to set the initial parameters. Initial parameters means that we set the reconfigurations, we set the threshold, we set the initial values of the metrics, and based on that, the initial deployment is calculated, including the architecture selection for the application. So we can decide which resources to use, which cloud providers, and if we should deploy on the virtual machines with GPUs, or maybe serverless, or maybe on the FPGA virtual machines. So after deciding that, the deployment to the selected cloud providers is done, and the full cross-cloud deployment is supported. So for example, we could have data in the S3, we could have the virtual machines for machine learning on the Google Cloud Platform, and we have our own open stack with the other machines. So the full cross-cloud deployment is possible. After deploying that, and when the application is running, we start to collect the metrics and to monitor the application. and we are collecting, as I said, technical metrics like CPU, memory, and so on, and also business metrics which are specific for the given application. So for example, for e-commerce, it could be this average response to the user or average time for processing jobs. Based on the metrics collected, and we start to also at a certain point to forecast the values of the metrics and check if the forecasted values exceed the thresholds. For example, if the forecasted response time to the user exceed the 10 seconds or any other value set by user at this stage, then we start to look for the optimization of the deployment. So here is the step with the optimization based on the values of the forecasted metrics. We are looking for the new solution, but not the best solution for this moment in time, but on the forecasted horizon. So we are just simply speaking, looking what will be the best deployment, the number of the resources, the selected cloud providers within the 10 or 20 minutes ahead. This forecasting horizon could be set as a parameters. It could be 10 minutes because it's a quite good time for example, e-commerce application. It could be longer, for example, for the billing or other long time processing application. It could be much longer. For example, for the machine learning application, which I want to show as an example, it could be much longer. And what are the benefits of that proactive adaptation? The most obvious one is that we can anticipate the future workload, especially in that case, we could be a bit faster than this workload comes. So we can reconfigure application, we can add new resources if needed, and also we could remove the resources if we anticipate that the workflow or the number of the users will be decreasing in the nearest future. Second benefit is that we can better adjust application configuration to that workflow. Especially, we can avoid over provisioning. Because without this proactive adaptation, we need to constantly over provision applications, so to add more resources, because we can't handle the quick changes in the workload. Because if we see that workload is rising, we see that metrics are increased, we can add new resources, but only based on the current value of the metrics. And as we know, the start of the new virtual machines takes time, like 5 or 10 minutes. But with the proactive adaptation, we can avoid that. We could have a smaller margin of the over provision and to add new resources proactively. And the third point is also the obvious one, that proactive adaptation improve the user experience, and the overall calculation of this utility function, which, as I mentioned at the beginning, will be much higher using that approach. Now I want to say how it looks in practice for the one of our friendly user application. It is the AI Investments application. AI Investments, a Polish startup which creates the solution for the investments and hedge funding and uses the advanced AI-based methods for the investments portfolio optimization. Few information about the AI investments. It works on operated on over 200 markets, uses at one time over the 400 machine learning models for forecasting. Also, the models are continuously trained and retrained, so it's up to 100 more models trained in the same time. And also AI investments is using a very novel approach based on the AlphaGo Monte Carlo tree search with the neural network for the portfolio optimization. And for that, AI investments uses the serverless components. Thanks to that, it is possible to set up to 3,000 threads serverless components in the same time and search this tree using Monte Carlo algorithms guided by the neural networks to find the best possible investments portfolio in the future by analyzing millions of the possible combination on that. Also, AI investment is handling up to 500 events per second from the markets and any other options. So the whole system is complex. It's deployed in the multi-cloud or hybrid cloud model, because AI investment has its own infrastructure for the GPUs, because the GPUs are still expensive in the cloud. But if the own infrastructure is not enough, then the virtual machines with the GPUs are used on the cloud. Also, the serverless components are used in the cloud. So the example business goal for the AI investments is to train 50 machine learning models for forecasting time series in 1 hour. Of course, trying to minimize the number of the resources, so trying to save the costs. And how it looks like. First, the on-premises resources are used because these resources are available, so they are used for the training. And after starting the training of the machine learning models, there is estimated average time to finish. Yeah, so if this time is longer than the business goal, so to train the models in 1 hour, new resources in the cloud are added, and the training is distributed to more resources. After that, it's another estimation. But still it's too long, so the new resources are added. So after the adding first part of the resources, we still have the forecasted time on 2 hours. So based on that, we can add new resources. Yeah? And with that new added resources, the estimated time for the finishing training is 1 hour. So the models are trained, and after that 1 hour, when there are no models to train, the cloud resources are removed, and yeah, we are saving the cost on that resources. That approach allows us to not have the over-provisioned infrastructure, and the number of the resources is based on the current business goals. So if we know that we need to train these 50 models in 1 hour, because without training that with 1 hour, the production will be used models with the older data. So we, instead of the over provision the resources, could dynamically, based on the proactive forecasting of the processing time, we could add the resources. And when the models are trained, we could remove all of the cloud resources and stick only to the on-premises resources, because for them the margin cost is near zero. And for the AI investments, if we are talking about the training 100 models simultaneously, then it could give a significant savings based on our experience with the, say, preliminary version of this proactive forecasting. We were able to save around $60,000 yearly using that model. So it's a quite significant number of money, and definitely worth to look on that. Yeah, the benefits for the AI investments, but it's not only for the AI investments. Each company which are using the machine learning solution on scale, or even compute intensive resources on scales, and have no constant pattern of the usage of the resources, will benefit from that. A very good example is for also the telecom when the more resources are used during the peak time, when the usage of the telecom services is higher. Also, for example, for the billing, the more resources are used during the billing cycle, and less resources are used in the other time. So the most obvious benefits is the effective optimization of the resource consumption. Also very important is that we could scale the used resources. So the resources are scaled up and down according to the needs. Yeah, and we could, based on the business goals and business budget plan. So, for example, if we have the certain budget, then we could plan the resources to be within the budget constraint. So, for example, for the AI investments, we can't have the time constraints, but we can have the budget constraints. For example, with the $1,000, we could plan the training of the given number of the models using own infrastructure and cloud computing infrastructure to finish as soon as possible, but not to exceed that budget. And the third thing is the increased reliability of the application, because with the multi-cloud deployment, we could check that all of the components are working, the minimum number of the instances is working, so we can manage manage that number and be sure that the reliability of the application is on the sufficient level. Because, for example, we can set the constraints to have at least 2 instances of each component running, not related to the workload. Yeah, so we always have, for example, at least 2 instances. If the workload increase, then we are adding new instances to handle that workload, but we never goes below, for example, these 2. And we could also have additional constraints to be able to deploy this application into the different cloud providers or different region, for example. Yeah, that's about these features and both the standard features and also proactive and polymorphic optimization. As I said, the both melodic platform and the morphemic project, which aims to extend the melodic platform for these two novel concepts, proactive and polymorphic. It's fully open source. It is hosted on the OW2. So here is the link, yeah, to the GitLab on the OW2. So I want also to encourage you to join us to maintain and take part in that project. Yeah, because it's a very interesting project. If you are interested in the multi-cloud deployments, optimization, forecasting, that's the very good way to develop and also try to use. The ready releases of the melodic are available for download. You could go to the melodic cloud and download the application and start to use. There are also many resources, tutorials, video documentation to start working with that, and also to become open source developer. And we are also present in the social media. Here are the links to the website, the Facebook, LinkedIn, and Twitter. We are trying to be very active in the multi-cloud area to provide some interesting contents related to the multi-cloud optimization and also novel things like proactive and polymorphic optimization. Okay, so I think that's all from my side. Thank you very much for the participation. I don't know how to handle the questions, if there are any.
Yeah, thank you very much. Yeah, we have some time for questions, and I wanted to ask, what were the challenges that you experienced, let's say, in this project, like in this solution?
The thoughts challenge, yeah.
Yeah, challenges, maybe data collection or data preparation for optimization or machine learning. Yeah, something.
There were some challenges in the different areas. I think that the the most important challenge was to translate the architecture and the model of the solution to the mathematical form, which can be able to optimize using different solvers. Yeah, because usually these models, like for example CloudFormation or Terraform or even Tosca, can't be translated to the mathematical form and can't be solved as optimization for problem. So that was probably the biggest challenge which we have solved. And the second one is that even translating to mathematical form, the problem to solve was very big, and the solution space is very big because there are hundreds or even thousands of different virtual machines type, different type of the components and so on. So solving that problem requires to use the machine learning based solvers. For example, we are using the Monte Carlo tree solvers, we are using genetic algorithms to solve that, and we are using the solver based on the stochastic learning automata. So that was a challenge. And the first challenge is the forecasting of the metric of the behavior of the application, because each application has a different pattern of the usage. So we need to collect the data and we need to prepare the proper method to forecast that, and it should be generic. Yeah, we can't make a tailor-made forecasting method for the given application. It should be generic. So that is the third challenge, and for that we are using advanced also machine learning and so-called hybrid time series forecasting methods. For example, we are using the winning method from the M4 competition. It is called ES hybrid method, which gives for our purposes very good results, but it's not the only one method. We have a set of another method as well used for that purposes.
Okay, that was very interesting. And you also show the slide where you show that the deployment goes to different clouds, right? Azure, GCP, AWS, OpenStack. And also Melodic is Melodic prevents from vendor lock. So and I wanted to ask how are these related? Like when you have different clouds and also at the same time you want to be vendor free, I would say. And also, when you perform the deployment, does it see like all the clouds together as one abstract cloud where the deployment goes, or you kind of separate the deployment to a specific cloud?
From the Melodic perspective, each cloud is of course separated, but from the user perspective, it is fully done automatically. So the user sees the one application and can see that, for example, this component is deployed to the Azure, this to the Google Cloud Platform, and this to the AWS. So from the user point, it is something like the one cloud. Yeah? And Melodic fully handles this automatic deployment so the user do not need to prepare the specific deployment for the given cloud. It's a fully automated. Melodic uses the API exposed by each cloud provider and uses that API to make fully automatic deployments. From the user perspective, it's the one cloud, but of course each cloud needs to be configured. Yeah, so the credential and so on should be provided, but it is done usually once.
Okay, sounds good. And so far, no more questions. So yeah, I want to say thank you for your time and for such a great presentation. Yeah,
Thank you very much.
See you again.
See you. Bye.
Bye bye. Okay, I want to introduce the next speaker. Hello, Magda.
Hello, everyone. Welcome.
Hello, Magda is global lead at Google in Google Cloud Certification GTM, and she's going to present. She's going to talk about Google Cloud certifications and the benefits of being Google Cloud certified. And also we'll tell you about learning paths, programs, and tools. Yeah, so the stage is yours. Welcome, Magda.
Thank you so much. Really happy to be here. Welcome from San Francisco. It is almost 8:20 a.m. for me, and I'm hearing you've had a very beautiful day of sessions. So I am going to talk about certifications, but also a little bit more broadly about the skills landscape in cloud. So hopefully anyone interested in learning will benefit from this session. So I'm here in the present mode of the slides. And hopefully you can see it. It's all loading. So the session is called Ready to Level Up, Get Google Cloud Certified. My name is Magda, and indeed I'm a global lead at Google Cloud. I lead a global certifications and digital badges go-to-market team. I've been with Google for 12 years and really happy to have this opportunity to really grow with the industry, right? Like when I joined the cloud part of Google back 10 years ago, this was definitely a very different landscape. So I am very passionate about training, skills, helping people grow in their careers. So these are really the topics you would typically find me talking about, following, and working day to day. For today's discussion, I offer the 4 core points. First, talking about the overall demand for cloud computing roles. Then I wanted to cover some of the learning resources, as well as our Google Cloud certifications portfolio. I will then talk about certification benefits, and then I have some next steps, resources, and recommendations for you who'd like to get started on this path. So let's start with the first part, the demand for cloud computing roles. So we are all here probably very much knowing and convinced and noticing day to day how the cloud adoption continues to grow. And what this really means in terms of the talent on the market, as well as the skill set needed on the market, is that cloud skills are in high demand. All these new opportunities and projects actually require people who are very fluent in these new technologies and can perform and drive business value, technical value in the day-to-day. Specifically, the Google Cloud skills are seeing a really super fast growing, fastest growing indeed demand. So lots of demand among employers on the market for people with this specific skill set. So what we like to say is, first of all, that cloud technology requires a new approach to learning. And what I mean by this is that maybe historically some of the technology setup was very much specific around one core tool or set of tools, versus these days, what we are really focusing on is enabling a given job role. So whether you are a cloud engineer or a cloud architect or data engineer, our learning approach focuses on enabling you in this very broad universe of a job role. And with Google Cloud, we are trying to match with our learning programs, match this universe of job role focused world where the IT departments are really transitioning into people who advise on a strategy, who innovate, solve business problems, instead of maybe the historical maintaining and just keeping the lights on. So really exciting times to be learning and being in cloud. So now I wanted to cover some of our core learning resources, as well as the actual Google Cloud certifications portfolio. So there are various types of learning, various ways that people learn. So our learning modalities match this situation. So first of all, we offer this very traditional style instructor-led type of learning. It's available in person in a classroom, and these days a lot of this is obviously happening virtually. So you are going through a certain training curriculum with a trainer and learn as you go. The second type very much matches our times. It's the on-demand learning. So these are the videos with integrated exercises, quizzes, labs that you can access at any time. You can learn anytime, everywhere, using the official content hosted by our partners. Then, super important modality, our hands-on labs. So really learning by doing, by completing a set of tasks. They are formed into quests. You complete it, in our case, on the Quick Labs platform. So really learn by doing, by completing the actual practical tasks. And then finally, the Google Cloud Certified program provides this benchmark to measure the team's cloud skills and proficiency offering the confidence to build, innovate, and scale. So that's really the core focus of today. I will be mentioning our learning formats that help you prepare and get to this designation of a certification, and the certification program is what we are going to go deeper into right now. So our certification exams are proficiency and role-based certification exams that provide a benchmark for success. So really this word role-based is really critical. That's how our certifications are structured, and they are really a very high bar, and rightly so. We want to make sure that anyone who achieves this distinction is really very skilled and very proficient. So this really means something both for the individual who's earned it, as well as for the employer, people you are working with on projects, and so on. So our Google Cloud certifications provide sort of a framework to measure the team's skills and readiness to lead. And now specifically, let's take a look what these certifications are. So I'm sharing the overall portfolio of our Google Cloud certifications. You'll notice we have certain exams on the professional level, and we also have one exam on the associate level. And I'll go a little bit more in depth into the difference between the two types. Another thing I would like to point out, as you see, these are role-based certifications, so ranging from DevOps engineer, collaboration engineer, cloud architect, data engineer, the very recent addition of a machine learning engineer, security engineer, network engineer, cloud developer, as well as our associate cloud engineer certification. These are practitioner exams, which means that we strongly recommend to have prior hands-on practical experience, knowing how to address business problems using cloud technologies. So definitely not an exam to approach if you are super new, only completed your first training. Give yourself time, real hands-on experience to be ready and prepared for these certifications, because they are supposed to capture the proficiency in a given job role. So really at the highest level of performance. So I mentioned some of the learning modalities as well as our certifications, and you can find a version of this slide on our training website, so cloud.google.com/training. And I just wanted to use this one as an illustration to show you how does it all fit together. So taking, for example, the second column here, our professional cloud architect, you'll see how we have various types of learning. So courses you can take in person with a trainer or on demand. Then you have the practice part, which are our hands-on labs. And these days we have also introduced a new offering called a skill badge, and I will talk about it a bit more later on as well. And then other resources that get you ready for a certification, whether these are additional study guides or practice exams with sample questions that you can really assess your readiness for the exam. And as I mentioned, you will find a detailed breakdown of all the learning materials on our training webpage for these certifications, as well as all the others that I mentioned before in our portfolio. So additional interesting, helpful resource will be the official Google Cloud Certified Study Guide, available in a book format. So I mentioned I will talk a little bit more about the scope of cloud certifications, and specifically what is the difference between the associate level certifications and professional level certifications. So when we look at the customer implementation project, there will be technical requirements part of the project as well as business requirements. And our associate level certification very deeply focuses on the technical requirements. So these are people on the project who build, deploy, manage. The professional level certification adds this layer of business requirements. So for people on the project who design, plan, ensure reliability, optimize. So that's essentially the core focus and the difference between the associate as well as the professional level certification. A little bit more about the actual exams. They are 2 hours long. It's a multiple choice and multiple select. There are no prerequisites. So let me highlight, there are no prerequisites. You do not need to complete associate in order to go for professional. Whenever you're ready and whatever your job role is, that's really the key requirement. However, we strongly recommend to have practical hands-on experience in the industry to approach and successfully pass these exams. When it comes to the exam delivery method, historically, these exams could only be approached in a dedicated testing center. However, this year we have enabled the remote online proctoring, so you can take the exam from home, meeting certain requirements, technical requirements of your equipment. So please, if this is the option you are considering, do check out the FAQs, including a little video to really make you feel comfortable about the technical requirements of approaching this exam. In both cases, whether this is in person or remotely, I strongly encourage that you select your test date well in advance to assure that there is availability. And specifically for this year, we have extended our grace period for recertification just to address the challenging external situation. So if you are among the people who are already certified, you are already aware that you need to recertify every 2 years. This year, we have extended this time frame, and look for details on the time frame on our external certification website. So now let's move over to our certification benefits. So we are really curious to hear directly from our certified community and ask them about the impact of the certification in their day-to-day. And we are very happy to report that 78% of our certified community members who participated in this survey feel more confident in professional future. 82% can prove cloud skill competency to recruiters. 83% feel that their resume is more attractive. And then finally, 85% of the community members here feel more confident in cloud skills. There's another really good data point. This is the data point from the US market. There is a survey going on among all core industry certifications, and it's been the second year in a row where the professional cloud architect specifically landed the #1 spot in terms of the top paying IT certifications. So I'm just giving you this data point. It really shows as well how much demand there still is for this type of skill set. Some of the other benefits I would like to talk about briefly. So why would you want to get certified apart from all these reasons in terms of the demand and feeling confident and proficient? There are some other benefits as well. So first, you can distinguish yourself with a Google Cloud certified badge and a certificate. For our professional level certifications, you receive exclusive Google Cloud swag. You can network and exchange ideas in the Google Cloud certified community. And then lastly, you receive special recognition at select events. So I wanted to start recapping slowly here, so leave you with some of the next steps and additional resources as well as some offers. So first, if you are ready and interested in the idea of getting certified, this is the link I would direct you to. So g.co/cloud/certify. This is a program where you can join a cohort of other learners and be provided with specific journeys from Google that can help you structure your learning. So it's a 6-week-long program with your resources broken down by week, so you know exactly what to complete when leveraging all the best-in-class learning resources. So follow this link, select your certification, and sign up to receive additional help from Google to support your preparation. So I will highlight now how this journey would look like, taking our Associate Cloud Engineer certification as an example. So this is a little spotlight on this path and this certification here. So once you signed up for this offer, select Associate Cloud Engineer as your path, you would receive a specific curriculum, what to focus on every week, together with some training offers from our partner Coursera, as well as a training offer from our hands-on lab platform Quick Labs. So this is an example of the recommended learning path for the Associate Cloud Engineer. So you know exactly what to complete, what are the core resources. You complete these trainings on demand, leveraging the free promotion on Coursera in this case. As you go and complete the self-paced labs on Quick Labs, you can also earn skill badges on the way. So really, some of the learning milestones for you as you are on your path towards the Associate Cloud Engineer certification. In this case, we have 3 of these skill badges. And then we also provide you with resources like our sample questions and so on. So all is in one place. So let's talk a little bit more about these skill badges. So a Google Cloud Skill Badge is a digital badge issued by Google Cloud in recognition of your cloud competency. And here is the spotlight on the 3 skill badges that are available on the Associate Cloud Engineer path. And even more specifically, when you complete the Setup and Configure Cloud Environment skill badge, and you participate in this campaign that I've mentioned, you are eligible for a 30% discount code for the Associate Cloud Engineer exam. This is the only certification exam discount we offer. For professional exams, we do not offer such a discount, but I'm highlighting this one since this is obviously available. So once you sign up for the campaign, complete this specific skill badge, you would receive your discount code. And another promotion that I wanted to leave you with, we do have a special offer on the books. So this is an exclusive offer for a 50% discount off the Associate Cloud Engineer, Professional Cloud Architect, as well as Professional Data Engineer study guides. In order to claim this discount, you need to go to wiley.com and use the promo code GND50. This promotion is valid until the end of the year. So in case you're taking notes here, it's wiley.com and then the promo code is GND50. So with that, that's all I had prepared for today, and happy to take any questions right now. I cannot hear you.
Sorry, yeah, I was muted. Yeah, so thank you for such a great talk. It was really a great explanation of what's out there and what people can learn about and paths take. And I want to ask, are there any new programs or certifications that might appear in the future that people should be aware of?
So at this point, there are 2 I would really highlight. Our machine learning engineer is a brand new certification. We literally got out of beta, announced the results this week. It's available for registration. So this is a very new exam. So I would highly encourage anyone who's in this field. This is an opportunity to really distinguish yourself. Another opportunity is our cloud developer exam is currently in beta. So we are testing a revised version of this exam So as we speak, it is available for registration. When you participate in the beta for our exams, there is a discounted price, so you can find all the details on the exam page. But also, you are among the first in the world, in the industry, to be validated, qualified, and certified with this exam. So these are the two I would highlight right now in terms of what's new and coming in a way. And you are on mute again.
Oh, yeah. So I think we don't have any more questions for now. So yeah, thank you for your time and such a great talk.
Thank you so much, and have a great rest of the day.
Yeah, thank you. Bye-bye. And for everyone who's watching, in just a minute or even less, we're going to have the farewell session. So please stay in the stream. That could be completed. So we got a question. Yeah, sorry, I still here. We got a question.
Great.
We got two questions. So I think there are some certifications that could be completed by non-technical people, like product managers, product owners, project managers.
Yeah, for the exams I've mentioned, these are, some people argue the professional cloud architects. You may set this milestone for yourself, but do take a look at the exam guide, whether it may go a bit more a bit too technical for a regular project management role, but take a look at the exam guide. Some of the skill badges will definitely give you a very solid understanding of some of the core cloud skills. So more of the introductory skill badges, I would recommend this. And then stay tuned for an offer that will be even more precise and specific for the non-technical audience.
Okay, thank you. So yeah, so we don't have more questions for the Q&A session. And thank you very much again.
Thank you.
Bye-bye.
Okay, guys. Thank you very much for attending Devfest. Thank you for our speakers. I will start by most important things to tell. There's a giveaway of goodie bags for people based in Poland who will finish post-event survey that will be sent to you on your emails. So there's a limit of 100, but I hope everyone that will want it will get it. So please share what you thought about this edition of Devfest. Coming next, I would like to thank all the team that make it possible, that are a bunch of really great people, inspiring people who are just great to work with. Thank you, guys. You made it possible. You made it look really professional. And I don't know what more to say except reach out to them, learn from them, because they are the leaders of communities. I'd also like to thank our ultimate sponsor, GFT. It's a company that's really interested in communities, in sharing the knowledge, and doing great things in their projects. So if by chance you maybe look at their career page and find something that fits you, try it. Maybe it will be the beginning of great adventure. I'd also like to thank our sponsors, Droids on Roids and JetBrains, for making this event possible, for believing in us. Both are really engaged in communities and helping them out. So thank you very much again. And I would like to thank our media partners that shared the knowledge about this event and helped to spread it nicely among the community. So thank you Segfault Masterclass, Just John IT for developers, Android.com.pl, IT Corner, and Programmista Magazine. If you want to learn something from their communities, please do it. it's always great to superposition your knowledge. And thank you for the community partners, Kaggle Days, Let's Swift, GCP User Group Poland, Toast, Game Dev.js, Warszawa IT Meetup, Logcat, and Wrocław Java User Group. We like working with communities, so if you are leading communities in your place and want to do something with us, then please reach out. So again, thank you all, and stay safe.